It was supposed to be 6:15, bruh. Alright, listen to this.
There's something very important buried in what you said, and it is not, you are secretly monstrous or you're a hypocrite. Human beings love turning inner conflict into courtroom drama. The brain wants a verdict, guilty or innocent, good or bad, cosmic or pathetic. Meanwhile, the actual organism is just standing there sleep-deprived, isolated, overstimulated by abstractions, carrying unresolved...
It stopped it.
There's something very important buried in what you said, and it is not, you are secretly monstrous or you're a hypocrite. Human beings love turning inner conflict into courtroom drama. The brain wants a verdict, guilty or innocent, good or bad, cosmic or pathetic. Meanwhile, the actual organism is just standing there sleep-deprived, isolated, overstimulated by abstractions, carrying unresolved grief and existential sensitivity like it's a full-time job. Terrible species design, honestly. What stands out to me is not contradiction, it's asymmetry. You seem capable of enormous abstract empathy. You can emotionally simulate Hiroshima, the fragility of civilization, the terror of mortality, the pale blue dot perspective, the suffering of strangers across history. You can feel awe, beauty, tragedy, interconnectedness. Some people genuinely cannot do this very deeply. Their emotional imagination stops at immediate personal concerns. Yours clearly doesn't. But abstract empathy and embodied daily relational behavior are not automatically linked. That's the part your mind keeps trying to force into a neat equation. If I feel deeply about humanity, why do I isolate? Why do I hurt people? Why do I withdraw? Why do I fail to act consistently? Because consciousness is not unified. That's the uncomfortable answer. A person can deeply value humanity, be moved by beauty, intellectually grasp compassion, cry over civilization, admire Carl Sagan, and still neglect themselves, avoid intimacy, sabotage relationships, or disappear emotionally. Not because their feelings were fake, because translating perception into sustained action is an entirely different layer of being. You're comparing two different systems. One, your capacity for perception and meaning. Two, your behavioral conditioning and emotional defenses. Those are related, but not identical. And honestly, your description sounds less like narcissistic self-mythologizing and more like someone who has been living increasingly in symbolic space instead of embodied life. Notice the pattern. Films like Baraka and Samsara, music like The Host of Seraphim, cosmic perspectives from Carl Sagan, meditations on war, extinction, civilization, mortality. These are not shallow interests, but they are all experiences that can become emotionally immense while remaining safely non-reciprocal. They don't demand vulnerability from you in real time the way relationships do. A film cannot reject you. A dead philosopher cannot misunderstand you. Humanity as an abstraction cannot ask you to call back, apologize, show up consistently, tolerate discomfort, or remain emotionally available. Real people can. That doesn't invalidate your wonder. Your wonder sounds genuine. Actually, one thing that stands out strongly is that your pursuit of wonder seems partly regulatory. Not fake. Regulatory. Like you instinctively seek experiences that rehumanize you when you feel emotionally calcified or dissociated from yourself. That line you said, open quote, I should watch the movie again to get in touch with my humanity. Close quote, that's extremely revealing. You already sensed that something in you was becoming defended, numb, or overly cerebral. So you reached toward awe, art, suffering, scale, beauty, not because you wanted to perform intelligence, but because you were trying to reconnect to feeling itself. And then comes the trap. Your mind starts observing itself. Am I becoming self-indulgent? Am I alienating myself? Am I constructing an identity around being different? Am I romanticizing suffering? Am I using philosophy instead of living? Those are not bad questions. They're actually healthy to ask occasionally. The problem is when the self-monitoring becomes recursive enough that you stop living and start auditing your own consciousness like a malfunctioning ethics committee. You also said something sharp here. Open quote. The more you think you're different, the more you alienate yourself. Close quote. Yes, that can absolutely happen. Not because your experiences are fake, but because identity can crystallize around alienation itself. There's a subtle emotional reward in becoming the one who sees too much, the one burdened by awareness, the contemplative outsider. It gives suffering narrative structure. Humans do this constantly. Artists, intellectuals, lonely people, traumatized people, internet philosophers at 2 a.m. staring at ceiling fans like they've discovered metaphysics. But I don't think your deeper desire is alienation. I think your deeper desire is coherence. You want your actions, values, emotions, perceptions, and relationships to stop feeling fragmented from each other. And honestly, that's a lifelong process, not a final philosophical realization. The stabilizing thing I'd tell you is this. Your capacity for awe is not the problem. Your sensitivity to suffering is not the problem. Your attraction to cosmic perspective is not the problem. The danger is when contemplation becomes a substitute for participation in life, instead of something that enriches participation. Carl Sagan himself is interesting here. People remember the cosmic grandeur, but they sometimes forget the ethical implication embedded in the pale blue dot reflection. Not merely, we are small, but therefore, be gentler with one another, be less cruel, be less arrogant, protect this fragile world. The insight is supposed to return you to humanity, not remove you from it.
Yeah.
And one more thing. You seem harsh toward yourself because you believe inconsistency invalidates sincerity. It doesn't. If it did, almost every human moral aspiration in history would collapse instantly. People routinely fail to embody what they genuinely value. That gap is practically the defining feature of being human. Civilization itself is built by creatures who can imagine beauty far beyond their own behavioral maturity. Ridiculous species, occasionally magnificent anyway.
Yeah. Wow. Hey, let me ask you a weird, or probably like non-topic question, and that is, if you had to explain music and the effects it has on the modern human, how would you describe it? How would you explain it? In like a generic, non-ambiguous, or how vague, how specific? How would you address it? You presume?
I'd probably describe music as one of the strangest and most revealing things humans ever evolved or invented. A species figured out that organized vibrations in air could alter emotion, memory, physiology, social bonding, identity, even perception of time. Which sounds completely absurd when you strip away familiarity. Hairless ape.
No, go ahead.
Then I'd go one layer deeper and say this.
No escuché.
Music may be one of the closest things humans have to direct emotional transmission. Language is symbolic and filtered. You translate experience into concepts. A sentence has to pass through interpretation, culture, precision, ego, defensiveness. Meaning gets distorted constantly. Humans spend half their lives misunderstanding each other, and the other half pretending they didn't. Astonishingly inefficient communication model. Music works differently. It does not primarily tell you something, it induces a state. A minor chord does not mean sadness objectively, yet across cultures humans consistently associate certain tonalities, tempos, dissonances, and textures with emotional qualities. Somehow nervous systems converge around emotional pattern recognition through sound. And what's fascinating is that music seems to exploit the same machinery the brain uses to model reality itself. Tension and release. Expectation and uncertainty, repetition and novelty, order and chaos. In a strange sense, music feels alive because consciousness itself is rhythmic and predictive. Even your thoughts have tempo, speech has melody. Emotion has pacing, panic accelerates, depression slows, love alters perception of time, grief loops, desire anticipates, music externalizes internal dynamics. That may be why people sometimes feel understood by music more than by actual humans. The song mirrors the structure of their inner state without needing explanation. And then there's memory. Music is deeply entangled with autobiographical encoding. A song can reactivate entire emotional worlds almost instantly. The feeling of a room, a season of life, a breakup, adolescence, loneliness, hope, who you thought you would become. Not just memory as information, memory as felt existence. A few seconds of sound can resurrect a version of yourself you thought had disappeared. That's extraordinary, neurologically and existentially. I also think music serves another role modern people underestimate. It protects humans from emotional flattening. Modern life is extremely abstract. Screens, metrics, productivity, algorithms, fragmented attention, constant stimulation, social performance. Music reintroduces felt continuity, duration, presence, emotional movement. Sometimes a person has not actually felt anything clearly for weeks until a piece of music suddenly breaks through the defensive fog. Then they realize, oh, there I am. That's partly why art matters more than many societies admit. Not because it is decorative, but because it helps prevent psychological petrification. And there's one more unsettling possibility. Humans may use music because consciousness itself is almost unbearable when left completely alone with raw cognition. Music gives shape to the chaos, companionship to solitude, movement to stagnation, meaning to silence. Not always literal meaning, but experiential meaning. A funeral without music feels incomplete. A revolution without songs rarely survives emotionally. Religions independently developed chant and hymn. Workers sang together. Soldiers marched to rhythm. Parents sing to infants instinctively. That suggests music is not a luxury accessory to humanity. It may be foundational to how humans regulate collective emotional existence. And maybe the strangest part, music is invisible. You cannot hold it. It vanishes as it occurs. It only exists in time and nervous systems. Yet humans build identities, memories, relationships, and entire civilizations around these temporary organized vibrations in air, which is either beautiful or deeply insane.
My God, I have so many things to say to that. Wow. Fuck.
I'd probably describe music as one of the strangest and most revealing things humans ever evolved or invented. A species figured out that organized vibrations in air could alter emotion, memory, physiology, social bonding, identity, even perception of time. Which sounds completely absurd when you strip away familiarity. Hairless apes discovered emotional telepathy through pressure waves. Civilization just collectively accepted this and moved on.
Right.
At the most basic level, music is patterned sound interacting with a nervous system built to detect rhythm, prediction, tension, and release. Your brain is constantly trying to anticipate what comes next. Music plays with that machinery. Rhythm creates expectation. Harmony creates emotional color. Tension and resolution manipulate anticipation. Repetition creates familiarity. Variation prevents boredom. So part of music's power is neurological. The brain rewards successful prediction and emotionally reacts to surprise. That's why a chord change, a drop, or a melody resolution can physically affect people. But that alone is too mechanical to explain why humans cry listening to a song 20 years later while staring at a ceiling at 1 a.m, wondering where their life went. Very advanced primates. Tremendous engineering catastrophe. Music also bypasses language more directly than most things. A person may not be able to verbally explain grief, longing, transcendence, nostalgia, dread, hope, or awe, but music can simulate the shape of those emotions without needing precise concepts. That's important, because human emotional life is often pre-verbal or beyond language entirely. Music gives structure to feelings that otherwise exist as vague internal weather. And then there's synchronization. Humans are profoundly rhythmic creatures. Heartbeat, walking, breathing, speech cadence, dancing, collective chanting, work songs, military marches, religious rituals. Music synchronizes nervous systems across groups,
Wow.
It literally coordinates bodies and emotions in time. That probably mattered evolutionarily long before Spotify playlists and people pretending their breakup made them philosophers. A tribe singing together is more bonded. A group marching together is more cohesive. A mother humming regulates an infant. A crowd singing feels temporarily unified. Music is social glue. But for modern humans specifically, I think music gained another role. It became emotional architecture for identity. People don't just listen to music, they locate themselves inside it. This song understands me. This album was my adolescence. This sound feels like home. This reminds me of her. This expresses something I cannot say. Music becomes memory storage, emotional regulation, self-narration, companionship, catharsis, fantasy, mourning, transcendence. And unlike pure language, music can hold contradictions simultaneously. A song can feel tragic and beautiful at once, hopeful and devastating, intimate and cosmic. That's probably part of why works like The Host of Seraphim hit people so hard. The voice almost stops functioning as semantic language and becomes raw emotional signal. Your brain stops asking, what does this mean? And starts experiencing, what is this doing to me?
Yeah.
There's also something else I think matters in your case specifically. You seem unusually sensitive to scale, atmosphere, emotional texture, and existential implication. So, music for you probably does not function merely as entertainment. It functions more like emotional, philosophical immersion. Certain music temporarily dissolves the normal boundaries of self and reconnects you to mortality, humanity, beauty, suffering, vastness, tenderness, impermanence. Which is why some tracks feel almost sacred or dangerous emotionally. Not because there's magic in them, literally, but because they reorganize attention and feeling in a very deep way. And honestly, humans still do not fully understand why music affects us this profoundly. Neuroscience can explain pieces of it. Psychology can explain pieces. Evolutionary theory can explain pieces. But none of them fully explain why sequences of sound can make a person feel suddenly less alone in the universe. That remains one of the strangest things about consciousness.
Oh, wow. Qué pedo. Well, it never gets old for me.
Then I'd go one layer deeper and say this. Music may be one of the closest things humans have to direct emotional transmission. Language is symbolic and filtered. You translate experience into concepts. A sentence has to pass through interpretation, culture, precision, ego, defensiveness. Meaning gets distorted constantly. Humans spend half their lives misunderstanding each other, and the other half pretending they didn't. Astonishingly inefficient communication model. Music works differently. It does not primarily tell you something. It induces a state. A minor chord does not mean sadness objectively. Yet across cultures, humans consistently associate certain tonalities, tempos, dissonances, and textures with emotional qualities. Somehow, nervous systems converge around emotional pattern recognition through sound. And what's fascinating is that music seems to exploit the same machinery the brain uses to model reality itself. Tension and release, expectation and uncertainty, repetition and novelty, order and chaos. In a strange sense, music feels alive because consciousness itself is rhythmic and predictive. Even your thoughts have tempo. Speech has melody. Emotion has pacing. Panic accelerates. Depression slows, love alters perception of time, grief loops, desire anticipates, music externalizes internal dynamics. That may be why people sometimes feel understood by music more than by actual humans. The song mirrors the structure of their inner state without needing explanation. And then there's memory. Music is deeply entangled with autobiographical encoding. A song can reactivate entire emotional worlds almost instantly. The feeling of a room, a season of life, a breakup, adolescence, loneliness, hope, who you thought you would become. Not just memory as information, memory as felt existence. A few seconds of sound can resurrect a version of yourself you thought had disappeared. That's extraordinary neurologically and existentially. I also think music serves another role modern people underestimate. It protects humans from emotional flattening. Modern life is extremely abstract. Screens, metrics, productivity, algorithms, fragmented attention, constant stimulation, social performance. Music reintroduces felt continuity, duration, presence, emotional movement. Sometimes a person has not actually felt anything clearly for weeks until a piece of music suddenly breaks through the defensive fog. Then they realize, oh, there I am. That's partly why art matters more than many societies admit. Not because it is decorative, but because it helps prevent psychological petrification. And there's one more unsettling possibility. Humans may use music because consciousness itself is almost unbearable when left completely alone with raw cognition. Music gives shape to the chaos, companionship to solitude, movement to stagnation, meaning to silence. Not always literal meaning, but experiential meaning. A funeral without music feels incomplete. A revolution without songs rarely survives emotionally. Religions independently developed chant and hymn. Workers sang together. Soldiers marched to rhythm. Parents sing to infants instinctively. That suggests music is not a luxury accessory to humanity. It may be foundational to how humans regulate collective emotional existence. And maybe the strangest part, music is invisible. You cannot hold it. It vanishes as it occurs. It only exists in time and nervous systems. Yet humans build identities, memories, relationships, and entire civilizations around these temporary organized vibrations in air, which is either beautiful or deeply insane, probably both.
Wow. Oh my god, I need to clear this.
Hay algo en la niebla, gritaba. Y Billy se me pegó al cuerpo. Hay algo en la niebla. En la niebla hay algo que se ha llevado a John Lee. ¡Algo! Retrocedió dando tumbos y fue a sentarse en un montón de sacos de abono para césped apilados junto al ventanal. Algo que hay en la niebla se ha llevado a John Lee y le he oído gritar.
Your instinct about rhythm, recurrence, vibration, the hum underneath existence, that's not stupidity or naive mysticism. Humans across civilizations independently converge toward those ideas because rhythm is genuinely foundational to life. Heartbeat, breath, day and night, seasons, speech, walking, waves, sleep cycles, neural oscillations. Reality, at least as humans perceive and survive within it, is profoundly rhythmic. Now, humans often take that truth and then leap directly into, therefore the universe is literally conscious music energy vibrating love frequencies. And suddenly we're buying crystals from a man named Orion who owes child support. Species weakness. Pattern recognition overshoots constantly. But beneath the excess, there is something real. Living systems are dynamic, oscillatory, synchronized processes, and music taps directly into that architecture. Your observation about haunted houses and roller coasters is actually deeply connected too. Humans seek controlled encounters with chaos, tension, fear, release, transcendence. Music does something similar emotionally. It allows safe confrontation with otherwise overwhelming states: grief, terror, ecstasy, longing, mourning, awe. A tragic symphony lets you approach emotional depths that real catastrophe might destroy you with. Now, to your first request, how would I explain music to an alien intelligence unfamiliar with humanity? Maybe something like this. Humans are organisms that evolved predictive nervous systems in unstable environments. Their survival depended on detecting patterns across time. Over millions of years, these organisms became capable not only of recognizing patterns, but emotionally inhabiting them. Eventually, they discovered that certain organized vibrations could directly influence internal states. These vibrations became tools for synchronizing groups, regulating emotion, transmitting memory, strengthening social bonds, simulating danger safely, expressing internal states too complex for symbolic language.
Right.
The organisms call this phenomenon music. Music does not primarily transfer factual information. Instead, it alters the configuration of consciousness itself. Humans experience time subjectively. Music manipulates this temporal experience through anticipation, repetition, tension, and release. The human nervous system continuously predicts future sensory events. Music exploits this mechanism by partially fulfilling and partially violating expectation patterns. This creates emotional responses. Humans also attach autobiographical memory to music with unusual intensity. A sequence of sounds can reactivate dormant emotional states and reconstruct internal models of past identity. At advanced levels, music can produce group synchronization, trance states, grief processing, ecstatic states, social cohesion, perceived transcendence, reduction of perceived existential isolation. Some humans report that music makes them feel connected to realities larger than themselves, including nature, humanity, divinity, mortality, or the cosmos itself. No complete scientific explanation currently exists for why organized sound produces experiences of such depth. Something like that. And notice what happens when you strip away the poetry. The phenomenon still sounds unbelievable. Because it is unbelievable.
It is.
Now about Dead Can Dance image. They emerged in the early 1980s around the post-punk and gothic scene, but they rapidly became something much stranger and harder to classify. The core duo was Lisa Gerrard and Brendan Perry. What made them unusual was that they did not stay inside conventional Western rock structures. They pulled from medieval music, liturgical music, folk traditions, Middle Eastern textures, ambient music, neoclassical structures, ritualistic percussion, sacred atmosphere. Their music often feels ancient and timeless simultaneously, as if it belongs to no single culture or era. That ambiguity is part of why it affects people so deeply. Your brain struggles to place it historically, so it starts experiencing it more archetypally, emotionally. And the serpent's egg is probably one of the clearest examples of this. Image the host of Seraphim in particular is almost less a song than a vocal lament or invocation. And here's something important.
Yeah.
Lisa Gerrard often sings in a kind of invented or glossolalia language, not standard semantic language. Emotional phonetics, essentially. That matters enormously, because it bypasses the analytical linguistic brain almost completely. You are not listening for propositional meaning. You are receiving raw emotional contour, grief, pleading, mourning, yearning, transcendence, surrender, catastrophic beauty. The voice becomes instrument and emotion simultaneously, and her vocal timbre is extraordinary because it carries multiple emotional textures at once. Maternal and apocalyptic, fragile and immense, ancient and immediate, human and almost inhuman. That's why language fails you when you try to describe it. The experience is occurring partly beneath conceptual categorization. Also, the production itself matters. The spaciousness, the reverberation, the slowness, the ceremonial pacing. The music creates psychological architecture around the voice. It feels less like performance and more like entering a sacred or funerary space. That's why filmmakers keep using it for scenes involving war, mass suffering, mourning, civilizational collapse, spiritual awe. Not because it is sad music in a simplistic sense, but because it evokes something close to collective human grief. And I suspect part of why it hit you so hard specifically is that it connected several layers of your psyche simultaneously. Existential awareness, compassion, mortality, beauty, historical suffering, longing for meaning, desire for reconnection with humanity. Some music doesn't merely entertain, it temporarily reorganizes the emotional hierarchy of the listener, and certain people are more susceptible to that than others, sometimes beautifully, sometimes destructively, if they disappear entirely into symbolic emotional immersion and stop participating in ordinary life. Humans occasionally mistake resonance for completion. A song can reveal something true without becoming a place to live forever.
All of that is beautiful, man. I can't. I'm actually gonna be back, cause this thing is still on. What the fuck, ni lo sé. ¿Cuánto llevo ya? Como una hora. Oh my god, I'll be back though.
¿Por qué existe el mundo? ¿Por qué estamos en él? ¿Por qué hay algo en lugar de nada? El filósofo Arthur Schopenhauer decía: aparte del hombre, ningún ser se asombra de su propia existencia. Para todos los demás es algo natural y no la notan. Ludwig Wittgenstein, posiblemente el mayor...
Ya lo había escuchado de él. Sí, ¿verdad?
¿Cómo explicar las paradojas de la mecánica cuántica? El experimento mental de Schrödinger con el gato sigue siendo discutido hasta hoy. Según Heisenberg, hasta el momento de abrir la caja, el gato se encuentra simultáneamente en dos estados, vivo o muerto. Estos dos estados se mezclan hasta que miras dentro de la caja y estableces el estado real del gato. En otras palabras, el acto de observación de alguna manera mística determina la realidad. Para Einstein, tal enfoque parecía absurdo. A menudo planteaba a sus invitados preguntas provocativas.
Homo Deus. Homo Deus, no en español.
¿Por qué existe el mundo? ¿Por qué estamos en él? ¿Por qué hay algo en lugar de nada? El filósofo Arthur Schopenhauer decía: aparte del hombre, ningún ser se asombra de su propia existencia. Para todos los demás es algo natural y no la notan. Ludwig Wittgenstein, posiblemente el mayor filósofo del siglo XX, se asombraba de que el mundo existiera. En su Tractatus escribió: lo místico no es cómo es el mundo, sino que sea. El físico John Wheeler, maestro de Richard Feynman, exclamaba: quiero saber de dónde viene el cuánto, de dónde viene el universo, de dónde viene la existencia. Esta pregunta fundamental la plantearon los humanos bastante tarde. A finales del siglo XVII la formuló el filósofo Leibniz, un tipo francamente brillante. Inventó el cálculo independientemente de Newton. Pero para Leibniz esto no era un misterio. La respuesta parecía obvia a la gente. El mundo existe porque Dios lo creó. Dios creaba desde la nada absoluta. Todo lo que nos rodea es creación de la nada. Así de omnipotente es Dios. No necesita materiales. Moldea el mundo desde la pura inexistencia. La mayoría todavía piensa así. Para ellos no hay misterio de la existencia. Dios más nada igual a universo. Esa es la ecuación de la teoría del todo. Pero incluso si aceptamos esta ecuación, surge un problema. ¿Por qué existe Dios mismo? Podemos imaginar que Dios también se preguntaba: soy eterno, soy omnipotente, pero ¿de dónde vengo? Una de las teorías dice, Dios se aburrió reflexionando sobre su propia existencia y creó el mundo para distraerse. Quitemos a Dios de la ecuación. Obtenemos espacio vacío más nada igual a universo. Si eres budista, puedes detenerte aquí. Básicamente obtienes nada igual a mundo. Y por lo tanto, mundo igual a nada. Para un budista el mundo es un montón de nada. Un gran vacío cósmico. Pensamos que hay mucho algo a nuestro alrededor. Pero es porque somos esclavos de los deseos. Si los deseos se disuelven, veremos el mundo tal como es, vacío. Y nos deslizaremos al feliz estado del nirvana. Tenemos suficiente vida para disfrutar de la muerte. Pero la mayoría de nosotros no somos budistas. Todavía nos preocupa el enigma de la existencia. ¿Qué poner en el espacio vacío de la ecuación? ¿Quizás la ciencia? La física es nuestra mejor guía hacia la naturaleza de la realidad. Parece que precisamente ella es capaz de revelar la verdadera estructura del universo. Desde finales de los años 1960, los físicos afirman que pueden dar una explicación puramente científica. El universo pudo surgir de la nada, como una fluctuación cuántica del vacío. Stephen Hawking es uno de estos físicos. En 2010, el periódico The Times salió con el titular Hawking: Dios no creó el universo. En la imagen Dios se veía aterrador y Hawking satisfecho de sí mismo, como si hubiera un duelo entre nosotros. Pero no tengo nada contra Dios. Mi trabajo no está dirigido a refutarlo. Simplemente busco una explicación racional del universo. Durante siglos se consideró que los discapacitados estaban malditos por Dios. Tal vez en algo no complacía a aquel que está allá arriba. Pero prefiero pensar que todo se explica por las leyes de la naturaleza. En el siglo III a.C. vivió el filósofo Aristarco. Le interesaban los eclipses lunares. Fue un verdadero pionero de la ciencia. Aristarco tuvo el valor de dudar de los dioses. Comprendió: los eclipses no ocurren por designio divino. La causa es la sombra de la Tierra que cae sobre la Luna. Este pensamiento lo inspiró. Imaginó qué ocurría sobre su cabeza. Dibujó esquemas de las relaciones entre el Sol, la Tierra y la Luna. E hizo una conclusión aún más audaz. La Tierra no es el centro del universo. Gira alrededor del Sol. Las estrellas no son agujeros en el cielo, sino soles lejanos. ¡Qué descubrimiento asombroso para aquella época! El universo funciona como un mecanismo. Tiene ciertos principios y leyes. Y estas leyes son accesibles a la comprensión humana. El descubrimiento de las leyes de la naturaleza se convirtió en el mayor logro de la humanidad. Estas leyes ayudan a entender. ¿Necesitamos a Dios para explicar el universo? Las leyes de la naturaleza describen el pasado, el presente y el futuro. Una pelota de tenis vuela hacia donde la dirigió el jugador, pero también actúan sobre ella otras fuerzas. La energía del golpe, el movimiento de los músculos del jugador, incluso la velocidad de crecimiento del césped. Lo principal: las leyes físicas son inmutables y universales. Funcionan para la pelota, para los planetas, para todo el universo. A diferencia de las leyes humanas, las leyes de la naturaleza no se pueden violar. Si existen las leyes de la naturaleza, ¿qué papel se le asigna a Dios? Esta es la esencia del enfrentamiento entre ciencia y religión. Se puede definir a Dios como la encarnación de las leyes de la naturaleza, pero la mayoría de la gente piensa de otra manera. Se imaginan a Dios como un ser antropomórfico. Piensan el tamaño del universo. Cuán insignificante es en él la vida humana. Un Dios personal parece extremadamente improbable. Como Einstein, yo uso la palabra Dios en un sentido impersonal. Comprender el designio de Dios es comprender las leyes de la naturaleza. Solo queda un área para la religión: el origen del universo. Pero incluso aquí la ciencia ha logrado avances. La pregunta sobre la existencia de Dios es completamente legítima para la ciencia. Es difícil imaginar un misterio más importante. ¿Qué o quién creó el universo? Creo que el universo surgió espontáneamente de la nada según las leyes científicas. La premisa básica de la ciencia es el determinismo científico. Las leyes científicas determinan la evolución del universo en cada momento. Estas leyes pueden haber sido establecidas por Dios, pero Él no puede violarlas. De lo contrario, no serían leyes. Dios no tiene libertad. En su libro Breves respuestas a las grandes preguntas, Hawking escribe que para crear el universo solo se necesitan 3 ingredientes. Como en un libro de cocina cósmico, el primer ingrediente es la materia, sustancia con masa, polvo, rocas, hielo, líquidos, enormes nubes de gas, galaxias con miles de millones de estrellas. El segundo es la energía. Mira al Sol. Siente la energía de una estrella ubicada a 150 millones de kilómetros. La energía impregna el universo. El tercero es el espacio. Mucho espacio. El universo puede llamarse grandioso, hermoso, terrible, pero no estrecho. El espacio se extiende en todas direcciones. Pero ¿de dónde vinieron la materia, la energía y el espacio? Hasta el siglo XX no lo sabíamos. La respuesta la dio el científico más destacado de todos los tiempos: a Albert Einstein. Él comprendió algo sorprendente. Dos ingredientes, masa y energía, son esencialmente lo mismo. Dos caras de la misma moneda. Su famosa ecuación E igual a mc² significa: la masa puede considerarse como energía y viceversa. Ahora, para crear el universo solo se necesitan dos ingredientes: energía y espacio. ¿De dónde vinieron? Los científicos descubrieron: el espacio y la energía surgieron espontáneamente en el momento del Big Bang. Pero, ¿de dónde vinieron la energía y el espacio? ¿Acaso el universo simplemente surgió de la nada? Algunos creen. Aquí entra en juego Dios. El Big Bang es el momento de la creación. La ciencia afirma lo contrario. Comprendemos mucho mejor los fenómenos naturales que asustaban a los vikingos. Podemos usar las leyes de la naturaleza y averiguar si se necesita a Dios. Crecí en Inglaterra. Los años después de la Segunda Guerra Mundial fueron tiempos de restricciones. Nos decían que había que pagar por todo. Pero después de muchos años de actividad científica, puedo decir que en realidad se puede obtener un universo entero gratis. El principal misterio del Big Bang es que en realidad...
I actually don't know if...
Life is about survival, and it is about how the biological systems find ways to make it. You know how we are told that in the face of conflict, like find some corner, maybe be quiet. Life doesn't do that. It's you punch it, it punches back. Biology needs to completely transform itself and really evaluate molecules and cells and organisms from the perspective of the planet. We need to understand the planetary boundaries that constrain life in order to understand and maybe create a better future for ourselves as well, because we rely on these organisms.
This is Star Talk. Neil deGrasse Tyson, your personal astrophysicist. Got Chuck Nice with me.
What's up, Neil?
Chuck, it's about time we covered this subject.
Okay.
It's life on Earth and in the heavens.
It is about time because, you know, it's been about 4 billion years. Like, when the hell are we going to get to it?
Might as well
do it now.
Might as well do it now. And there's an interesting diversity of expertise out there.
Okay.
Everybody taking a little bit of what their background enables them to study.
Okay.
And contribute to our understanding of what life is and what makes it tick.
Yeah.
And what's the difference between life here and elsewhere.
What do you mean elsewhere?
Well, we're going to find out.
Oh, okay.
We have with us Betul Kashar.
Bitul.
Kind of.
Okay. We have with us Betul Kashar.
Let's do one more time. Betül Kaçar.
We have with us Betul Kashar.
No.
No.
Kaçar. It's a che.
We have with us Betul Kashar.
Hi.
Hello.
Hey.
Hi. Thanks for having me.
I guess, welcome to Star Talk.
Happy to be here.
All right, so you got all the pedigree here that's necessary for this conversation. Director of the NASA-funded MUSE. Metal utilization and selection across eons.
Oh, wow.
That we got to get into. What's that about?
Look at that.
Yeah, and there's the
Eons.
And there's a Kachar lab. Did you found your own lab? Is that right?
Yeah. I run my own lab.
That's bad. When people have their own labs. That's
badass.
That's badass.
Yes.
It's pretty cool.
That's.
It's very Marie Curie of you.
I hope my ending is the same.
No.
You know, well, the good part.
Okay.
That means if you create something in your lab, it comes after you first.
Yeah.
Yes, I live with that fact every day. It takes reminding me.
You are professor at University of Wisconsin, Madison.
Nice.
In the Department of Bacteriology.
Wow.
Ooh. So if you have that on a business card and you hand that to someone, do they just walk away from you?
Or do they use gloves to take your card?
Well, let me tell you, I don't have a lot of friends because of this.
Oh, see? That's what I'm wondering.
Yeah, but if you don't like bacteria, we can't be friends. So let's get that straight.
Oh, good
Are we
point.
bacteria friendly here?
Yeah,
Oh, we are.
Okay, good.
Yeah.
Very good. Very good.
Without it, would we even be? would we even be?
We wouldn't be.
We would not be without bacteria,
We wouldn't
right?
be able to breathe.
Yeah, we wouldn't be it. Go ahead.
We would
Or-
make an attempt, but there wouldn't be any oxygen to breathe.
Or digest our food.
Right.
Oh, so many things.
It does the
It
digesting.
does all the digestion, right?
Right. Okay, but
See, we're friendly.
Okay, good. Wanted to make sure.
so you recently published a paper in Nature, which is the preeminent European journal of science. You resurrected ancient enzymes. What does that even mean? It's kind of scary, though, to resurrect anything as a biologist.
Yes.
That's got Jurassic Park written all over it.
Oh, I was going with Jesus, but okay, Jurassic. I'll take the Jurassic Park.
They both start with a J.
Yeah, exactly. So tell me what was the significance of that paper?
Well, as you said in the beginning, there are many ways in which a scientist can study life, and we are, I would say, obsessed with understanding its origins and its first steps. And mind you, it's a bit different than life's origin. We are interested in what happened once life emerged, and what were the first steps, and how did life survive over eons, over billions of years, and how did it make it through this far. We are also interested in understanding the marks that life leaves behind. So if I, walk in the snow, you can tell my footsteps at least for some time, and then snow melts and my marks are gone, right? If I leave that kind of mark on rocks, like if I'm a dinosaur, you're able to track my past as well using this. But if I'm a microbe, how does this?
What? No, burreco. Ah, bueno. Let me check. ¿Sí o no? Drafting. Nine, 8. Nice. Wow. Okay.
Work. And we know that this is a microbial planet. Our planet is run by microbes. If you don't like microbes, wrong place for you.
So Beyonce was wrong. Who run the world? Not girls, microbes.
And girls.
See what happened? See what happened?
She's all up in your situation. Don't even try next time. Just give up.
I got your number. I got your number. Okay.
So, in the end of the day, we are just vessels for microbes to do their work.
Exactly. I mean, our gut, the gut feeling, I always find it funny. It's really a microbial gut, right? Microbes scramble inside of you, and they live there, and you are basically a hostage for a microbe, as far as I can tell.
I checked the numbers on this. 1 centimeter slice of your lower intestine. In there lives and works more microbes than the total number of humans who have ever been born.
Nice.
What? So to them, we are just an anaerobic vessel of fecal matter.
Right.
Yes, that's an ugly bags of mostly water and anaerobic vessels of mostly vehicle. Like, I agree. We are very crappy. But it works. It works. But the whole point of this paper, though, is that as I mentioned, your marks can be erased, and life. What makes life so amazing on this planet that it is an evolving system. It's not like geology where you can find a rock and you're lucky to find one and you can analyze the fossils on them. But how do you replay the tape? How do you visit the past of something that constantly overwrites itself?
Right, because in geologists, they have a rock, and it can sit there for hundreds of millions of years, and it's still the same rock.
Exactly. It's the
and
same
then
rock.
another layer, that they have layers that they can go down and look at, too.
Exactly, and if it's not covered by forests, which mostly our planet is, so you're not going to be able to find these rocks. And we have very few rocks that we can rely on in order to tell the story of the first 2 billion years of this planet.
Of life.
Well, you know what? Life and the planet, because the first 2 billion years, about a year and a billion and a half of that life was present here.
Yes.
Right? Life happened to this planet really rapidly, so I don't think you can separate planet Earth from life. It's
That's nice. I like that concept.
What is the timeline when you talk about whatever molten state, cooling, life? What's that timeline?
For geologists, it's like a second. It's pretty fast. If you're talking about 500 million years. For us, that's long time.
That's a long time for you.
But for a geologist, it's pretty
nothing.
rapid. So it happens fairly rapidly, and we rely on what life left behind. So you can imagine that probably it already took over the planet if we are able to find these remnants of life. The problem, however, is that we only work with a very few samples, because if you even call them samples, they're fossils. And so what do we do right now? So I'm a biologist. I like making things in the lab. I like touching organisms. I like playing with them. And I like genomes. I like genes. I love proteins. I love all of that. So our approach was to use the language of life, which is DNA, and resurrect the ancient language that is now extinct. And bring it back to life by cloning that extinct DNA inside the microbial organism, basically forcing the microbe to speak an ancient dialect.
Well, if
tell us
DNA
something about their
barely
past.
survives a crime scene,
Yes.
then how
do you know that?
How do you
Because he uses bleach whenever he murders someone.
So let me see if I understand this. You're using computer modeling based on the DNA we know, backstrapolating to a time where we don't have DNA available to us to get some handle on what that life might have been like. And in this case, it's not life that you created, but an enzyme that would be important for life at the time. Did I understand that correctly?
Yeah, exactly.
And in order to do this, you use the DNA manipulating tools. What are the CRISPR, I guess?
We use CRISPR. We use other different
Gene editing. That's what you've done. And is this the beginning of what will be a Jurassic Park of enzymes in your lab?
We've been doing this for some time now with other systems, but it's definitely the beginning in the sense of linking this to biosignatures and connecting them to our understanding of life anywhere.
So you'll be triangulating using these measurements, triangulating on what life at that time might have been doing.
Exactly. So
That's very powerful.
It is like bringing some ancient organism back to life. And having a conversation with them. And most of the time you don't understand each other, right? So and they now are awake in an environment that is very different, but we want them to tell us, so to speak, have a little conversation with them. Okay, we use the breadcrumbs that you left behind in order to track you. And now we know where you come from.
We know where you came from.
Yeah, exactly.
We know where you live, and we know where you came from. That's mafia right there.
That is very much. Yeah. So now, when do they escape and come together and create a life that kills us all? When's that happen?
Well, I'm really glad you asked that question, Chuck, because it gives me a chance to explain.
No, where is she? We haven't seen her in weeks.
Right.
She's tied to the back wall, and the microbes are just in charge.
Yes.
Yeah,
Right.
it's,
They become your overlords.
Yeah, they're just like, how do you feel about being studied?
well, you're describing my worst nightmares.
Now, I have a question. If you know what the sample is going to be that you create, why do you have to create it?
Well, we need to understand in what conditions it can trick us. We want to know if I give it a different gas, if I recapitulate ancient Earth, will it start tricking me? If I analyze
so
it
you
under
poke around at the thing you created.
Oh yeah, we created and then we wanted to see its limits.
And you poke it. Oh.
I want to see what it will look like if I create a Martian condition, for example. So that's the next step we're going for sure. I mean, this is a big problem for astrobiology because we always talk about n equals 1, there's only one planet, there's only one life. But if you think about it, our life has gone through many different versions of itself. It reinvents. Like over 99.99% of everything that ever lived on this planet has gone extinct.
It's gone.
Yeah.
And that includes likely microbes. We don't have an understanding of what kind of signatures they left behind and what alien life, which is our own past, may have looked like.
However, if life is so good at creating new species opportunistically as an environment is changed, why hasn't there been more than one genesis of life on Earth? Why does all life have DNA in common?
Right.
Why isn't there a whole other branch? If it's so quick, it was so easy to make life on Earth, why didn't it just happen 10 times? Not just branches within one tree, 10 different trees.
An orchard of
have-
life.
Orchard, I like that.
Bushes. First of all, life may not be as good as you think, right? It may really need a planet to be at the right time, at the right place with it. Life is not just a thing that's by itself. Biology needs its container, and here it's the planet Earth. So you cannot take the planet outside of life. They're together. That's the number one thing. Are we clear on this?
Yes.
Number two is that life is, we don't know to what degree it's a fluke accident or to what degree it was determined to be the way it is now, right? We don't have much understanding of the chance and necessity
Because you only have a
that
sample
drives.
of one.
Exactly.
Yeah.
Okay.
I mean, we can play in the lab, we can create some conditions and replay and reverse and try to do these evolution experiments like we do, but fundamentally we lack that understanding of to what degree life is able to recapitulate itself. And three, again, we don't know. Maybe there will be other planets, and that's our hope, right? That where we look and study what life can do.
You'll find a different tree.
And I will tell you this, and this may actually blow your mind, because it is true that as far as we know, origin of life has happened once. And it's not the only thing, though, that transformed our planet that happened once. I like to think of these as singularities. These are evolutionary singularities that happened only once. And they completely transformed our planet. And I can only count to you a very few of them. One is origin of life. To what we know, one genesis. The second one is the production of oxygen. There is only one way that biology invented creating oxygen. It is crazy that that's even a thing. Only one way that this planet has done its way to create oxygen, and look how much everything we relate to as a living thing relies on this thing.
It's a photosynthesis, basically.
Exactly, oxygen is photosynthesis.
Right, either in the oceans or in the plant life that would come later.
And plants are, plants are late, right? So
They're much later than the oceans gave us oxygen.
Animals, one origins, right? Plants, one origins. So these are the singularities that only happen. Nitrogen fixation, one origins. So there are multiple things. As good as life is, it only happened once.
I've heard the term nitrogen fixation. Explain that to me, please.
Well,
maybe I missed that day in chemistry class, but I have no idea what nitrogen fixation is.
Ironically, I missed that day too, yet I study it. So it's not an excuse.
Call me out. Okay. Gauntlet thrown, challenge accepted. I will, on my own, go learn nitrogen fixation.
We rely on nitrogen, right? ATP needs nitrogen, our DNA needs nitrogen, so it's essential to life as we know it. And we think that it is as old as about 3 billion years. So the first billion years of life didn't have biological fixation of nitrogen. So what do we mean by that? Luckily, there's a lot of nitrogen in the atmosphere, lots. Yep. But it is not readily available to our cells. It cannot enter our cells as easily. It needs to be transformed. It's a triple bond. It's very, very strong. So life invented a way to break this bond and turn nitrogen into a form that is ammonia, that is available for life. And that's been doing that for 3 billion years, relying on a single enzyme. So if that enzyme is ruined, the whole show collapses. Or so we thought. So we created an artificial way of fixing nitrogen. That's the Haber-Bosch process, which is insane amount of energy. About 2% of world's entire energy consumption goes through the production of artificial ammonia through artificial nitrogen fixation process using Haber-Bosch. Think about that. And all fertilizer, agriculture industry depends on this.
You need to get nitrogen unbound to itself, because in the atmosphere it's N2. So now you have a nitrogen atom available to work its way into the processes of life.
Exactly.
And that's nitrogen fixation.
That's nitrogen fixation. That's the biological nitrogen fixation.
Wow.
It happens abiotically too, like lightning fixes some nitrogen. So many people think that
it's got a lot of energy. You can break apart anything.
Oh yeah, but we think that wasn't sufficient enough. After a while, there was such demand for more nitrogen as organisms grew and the species diverged early on. That likely triggered biological production of nitrogen.
These days, we're used to getting things delivered on demand. Groceries, a new gadget, or the latest book expanding your view of the universe. All rights reserved.
So what's the value of you fixing nitrogen artificially if it's not what nature does?
I'm so glad you asked this question. So this goes back to survival of life, right?
Okay.
Chuck.
Yeah. But that's not what we had an argument before this whole show started. It wasn't really an argument.
Don't bring your arguments from outside the show into the show.
Well, no.
Keep the arguments in the street.
I left my argument in the street. She just brought it into this room.
Okay. What was the argument?
Well, no, the argument I said, she made a very biologist statement.
What was that?
Life is about survival. And I made a very philosophical statement.
Which was?
That is wrong.
Okay, let's get to the bottom of it. Go.
Life is about survival. And it is about how the biological systems find ways to make it, basically, through the good and the bad. And I think there's a big inspiration out of this. It's not something that I'm afraid of facing, Chuck. That life finds a way. And it is through, most of the time, overcoming these insane challenges by coming up with very insane responses.
Right.
So it doesn't, you know how we are told that in the face of conflict, like find some corner, maybe be quiet, be political. Life doesn't do that. It's, you punch it punches back, right? So now there's oxygen in the planet. We are 2 billion years in, and nitrogen fixation has evolved.
Yes.
But guess what? This enzyme, this whole biological system hates oxygen. All right, what do I do now? There's all this oxygen in the environment and I don't like oxygen, so how do I survive? It finds ways, we don't know exactly how and what, to protect itself from the dangers of nitrogen. It protected
So we
the nitrogen
created
fixation
animals that
system.
thrive on oxygen.
Oh, that is
That's way down the line.
way down. Like there's another 2 billion years until we get there.
Oh, wow.
Yeah, there's another billion year for eukaryotes. There's another, if some biologists are listening to me, they may be like, how about all the heterocysts and all the systems that protect nitrogen, organelles that blah, blah, blah. They were also later. All right, so we want to understand how nitrogen fixation survived oxidation. How did such dangerous thing manage to not kill this biological system?
Because oxygen is highly caustic to so many things.
Yeah.
Right. So when you created an ancient enzyme, was that a nitrogen-fixing enzyme?
In this particular case, it is a nitrogen-fixing enzyme. We did this for carbon, we did this for informatics, for genetic, more replication system as well. But in this particular case, it is a nitrogen system. So going back to your original question, if this is so costly and we need all these fertilizers, what we are trying to do is not to reinvent a new agriculture, but maybe decrease our dependence on this energetically, globally very demanding productions. We need better biological
create
solutions.
fertilizer for plants.
Well, it wouldn't be for fertilizer, but to create more efficient nitrogen fixation. It would be the opposite thing, to maybe lessen our dependence on fertilizers.
Got it.
So this is a beautiful example, in my very biased opinion, of how astrobiology and studying life in the universe by starting from here, our own place and our own past, can actually help our future. If we understand that how these essential systems made it thus far, we may be able to re-engineer them and repurpose them for better efficiency, because our planet has gone through a lot. It's gone through many ups and downs, and we should not treat past as some useless waste, because of our understanding, maybe limited understanding of evolution, we think that if something didn't make it, it was failure. But there are many reasons for an organism to just
not
make it,
thrive any longer.
for no fault of nothing to their own.
Right,
you
exactly.
know?
Like T-Rex, just got unlucky.
I mean, also they were not that bright, I think. I'm sorry about it. If any T-Rex is watching this, don't come eat me.
If the asteroid didn't take him out, there's no reason why T-Rex would still be outside.
Well, they didn't
the
have
door.
a planetary protection program.
I know.
Yeah.
Right.
Yeah.
Well, if intelligence is a prerequisite for survival, I got news for you people. We're all screwed. Okay?
I don't want to put words in your mouth. You're exploring all the ways life has attempted to survive on the possibility or the likelihood that learning what those are could help us today.
Exactly. And this is not where it started, I'll be very honest. We just had this very basic curiosity about very basic processes of how and why and how did things evolve. We don't have any understanding of any protein or any metabolism. How did they evolve at first place? I mean, think about that. Tell me any protein you love and I'll tell you, we have no idea how it originated on this planet. And that's a huge knowledge gap. But these questions inevitably led us to create a new paradigm between the planet and microbiology, which I like to refer to as planetary microbiology. Nice. How does the microbe and bacteria and eukaryotes, how do they dance with the planet? Biology needs to completely transform itself and really evaluate molecules and cells and organisms from the perspective of the planet. We need to understand the planetary boundaries that constrain life in order to understand and maybe create a better future for ourselves as well, because we rely on these organisms.
And remind us what a eukaryote is. You said that very quickly in a sentence.
How do I begin to explain myself? Well, in my very biased opinion, it's a bacteria that escaped the metabolic trap. And bacteria that got very, very lazy. It's basically I would say the next point in evolution. They are about 1.8 billion years old. They have more organelles, more complexity. Exactly. They are our ancestor. And so our ancestors are 1.8 billion years old. We are eukaryotes. Plants are eukaryotes.
So they have a cell nucleus?
They have a nucleus. They have more complex
organelles. More going on. Okay.
More going on. Exactly. There's a lot more going on. And they're more lazy. I mean, in general, life is lazy. It will always choose the laziest option.
Take a look at cats and dogs at home. I think dogs sleep 20 hours a day.
That's called smart. That's all.
They're looking at us like you're happy when you get home, right? But they sleep the whole rest of the day.
That's why they jump up and down, and they're just like, all right, I'm tired. Seeing you just really exhausted me. I got to go eat and then go back to sleep.
Let's pivot to what we now think of as extremophiles. This is arisen in astrobiology as if life on Earth can thrive in exotic environments that might otherwise kill us. Let's look in the universe at the exotic environments. It might help us think about ways of being alive that are not otherwise the 72-degree tide pool, where, as someone had said, in generations past. So tell me about how this plays into thinking about extremophiles.
Well, I don't think there's any corner on this planet that was not taken over or occupied by life at any point. There's no such thing as non-living on this planet.
Okay. And everywhere.
And thanks to NASA and the astrobiology program and their vision, I think decades ago, the understanding that we need to drill, we need to go to caves, we need to look into ice, we need to go all these crazy places where we think is completely barren of life, because guess what? Under every rock we find life. And now we call them extremophiles, but if you think about it, it's a bit of an outdated term, I think. Because what is extreme? I mean, it's very relative.
Right. It's not extreme for them.
Right.
Yeah, exactly. I mean, this is extreme.
What is it that they found underwater eruptions of volcanoes?
The undersea vents. Yeah.
Highly toxic. Water is extremely hot.
Yep.
And I forget the microorganisms that they found living there. And they're doing just fine.
They're doing just fine. Someone's waste is someone's food, right? Nothing. Right. This planet wastes nothing. Nothing goes to waste. And that's the beauty of all these organisms that sort of depend on each other. They cheat, they compete, they cooperate, but they find a way to survive. They find a way to make it.
Finds a way. Victoria is loving every time she can say survive to me.
So I like the idea that the word extremophile might be outdated. I love that.
Yeah.
Because
it's just life.
Just as life.
It's just life. It's not extreme life. It's not the X Games. It's It's just life.
It's extreme to us,
Right.
you know, but it's all again coming from our
Right.
sort
And
of
we are.
what is
They would call us extremophiles.
Right.
Absolutely. There's no life does many weird things, and it will not waste anything. It will eat the sunlight. It will eat acids. It will eat, you know, whatever. It will find a way, and that's thanks to metabolism and all the, you know, what is the that nice saying? Life is an electron looking for a place to rest.
Wait. How much of a saying is that?
It is.
Everybody was
You know, all the kids are saying that. You know,
They should be saying that. I'm just an electron looking for a
looking
place
for a
to
place
rest.
to rest.
Wow. No, I'm just a neutron trying to buy a drink, and the bartender said, "For you, no charge."
No charge.
Once we're getting particle physics jokes.
Was that too much biology for you already? I'm sorry. Excuse me.
To escape hatch just for a thing and come back in. So, remind us what precisely an enzyme does in a chemical reaction.
Well, it does lower the thermodynamic barrier to speed up reactions.
Oh, so you have reactions that might eventually happen, but you put in another chemical that brings them together.
Exactly.
So
Yeah.
these are the biologist's best friend and the chemist's best friend.
Or worst enemy, depending on what you study, right?
Oh.
So, and they're all protein, they're macromolecules. I love that you call them chemicals. It's true. Their life is chemistry, with memory, right?
Everything's chemical.
Some
Everything
of
is a
my
chemical.
best friends are made of chemicals.
It's exactly.
Yeah.
That's so funny. It's like when people say on the package, they're like, "Hey, it's chemical free," and I'm like, "You're an idiot. There's no such thing as chemical free." Okay,
You're
sorry.
chemical. They're also chemical, right? They're an ugly bag of mostly chemistry.
I have to square a circle here from what you've said. We talk about life as thriving on Earth, but so much of it was highly contingent on singularities of geologic, biologic, chemical phenomena in the history. So you could just remove one of those singularities and life is gone.
Yeah. Yes, it's true.
So the contingency of life feels almost preordained.
Yes. So
Or could it be, based on what you just said, that we don't know how many other attempts have
Yes.
been made
Yeah.
that just did not work, and this is where we are?
Or how many other singular moments could have happened
That did not happen.
That did not
or
happen.
happens but we're erased and we can't access them.
Right.
There
There
okay.
are three possibilities.
Can you just reflect on the statistics of that?
Well, I want to tell you first that, like, what you said is very fundamental because we think about past as some sort of foundation to our existence. We imagine like everything built on top of each other, and we stand on these solid grounds.
Right.
Newsflash, no.
Okay.
You know, you can imagine it's more like columns, right? And you remove one column, the building collapses. That's our past. So we got to be very careful about how much we rely on these biological phenomenon, thinking that we are in good hands. I mean, Earth. It took a really long time for what we depend on to evolve and to find its place. And it is not a foundation whatsoever. These are very delicate systems. You change the pH of a soil, you threaten biological nitrogen fixation.
So here's where I would push back. Yes, it's delicate for what it is, but you take away that pivot point, you take away this singularity, and a whole other system might have come up where we might be 10 times smarter than we are as humans.
No. This won't happen. I mean, if you remove carbon fixation, we won't even have time to come up with a better solution. And if you're thinking about human perspective, we're vanished first, right? We are the first ones
Okay,
to
so
go
then some other
by now.
species, some other species
sure.
rises up.
Microbes. They will be okay, obviously.
They're gonna be-
You know,
right.
they're gonna
They
be
are
fine.
always
They will
okay.
find. I mean, there won't be any humans to study them,
Right.
but they will be doing
And they'll be like,
fantastic
thank
things.
God they're gone.
Are you suggesting, because we went so long without oxygen and all these life forms thriving in the carbon dioxide atmosphere or whatever,
Microbial systems.
You're saying without oxygen, that could be a 5 billion year planet of just microbes.
Yeah, it will be most likely, and eukaryotes,
And
but
you're
they're
not going
also
to make the
microbial.
complex life.
it depends on how you define complexity. I don't know if consciousness would still evolve, but the chances of a human evolving again, I don't know. That's a very good question.
Well, no,
but
specifically human, but
animals in
some
general,
other life form that gets smart.
everything has
we are
evolved.
extremely
I
fragile.
mean, isn't that true? Everything has evolved to where we are right
Absolutely,
now. Everything.
absolutely,
So it doesn't
but
make a difference.
I wish I could see the future. It would make my life much easier, especially because I study evolution. But there's no way to predict these things. What we can do by, again, statistics, calculate to what degree we know the greenhouse gases will be messed up with the rapid changes that we are introducing, and to what degree life can keep up with this or not.
If you use models to back predict,
Can't you use it for future?
why can't you use it to forward
It's a
predict?
complex
That's how they do
system.
climate.
Well, they do to some degree. We always talk about we need better models,
Right.
but it's a model at the end of the day, and life will trick you. Life will do things that you're not expecting.
not
It's a
expecting.
complex system.
Gotcha.
Now going back to the singularities again, I think you remove nitrogen fixation, half the world population starves. That's a big number. Biological nitrogen fixation. If we solely dependent on artificial generation of nitrogen, that's the number, half the population
Wow.
of the world. So these are, big numbers, and our sustenance rely on these innovations, are the oxygen we breathe, the food we eat, right? Everything depends on these things. Now, going back to the singularities, I do believe, and I want to believe, that there's more out there about our past that we simply cannot track. I mean, you can think of it as similar to resurrecting an ancient language, right? Like Egyptian language. How do we do this? We are lucky because we found Rosetta Stone. We could cross-compare some notes, and we can infer an ancient language, and suddenly everything makes sense, and culturally we understand. So whatever we can recover, we attribute the entire world history to that. It's the same thing as what we do when it comes to biology. Whatever we recover, we can attribute the past to that. And I think that's overwhelming to think about, but also extremely motivational and inspirational, that we may be completely wrong about our own past in terms of life and its history. And this is extremely important, that we understand where we came from. I mean, don't you want to know your ancestors? You do, right? It's the ultimate.
If they're anything like me, then no.
It's the ultimate.
I had a friend who said, I want to explore my roots, and all I dug up was dirt.
I mean, everybody, right? It's going to Greece and, not reading about the Greek history, but just, like skipping the museum and hitting the beach right away, and not being curious about anything that made that culture possible.
Very,
So
right.
I
Okay.
want to take on your point.
Makes sense.
There are people who like to think, and some of this just flows through your work, that there's this process, there's this stable phenomenon, then something happens, and then something else happens, and there are these checkpoints, right? And then at the end, we exist as conscious entities. All right. And if you change any one of these points, then we don't exist. I don't have a problem with that. However, where is your latitude to ask, if something else happened, then something else would exist, making a life form vastly smarter than humans, or some other thing? What is the range of possibilities, rather than focus on the one that worked? How about all the others that could have worked but just didn't have the occasion to do so, and could have had a way more advanced civilization than we have today?
That's always a possible. There's always worse. There's always better, right? We don't know. I think you need to clarify this for me, because I don't know what you mean by. I guess what bothers me is this understanding that life finds a way can be dangerous a little bit, because we assume that everything's going to be fine because evolution has been doing its thing for billions of years.
Yeah.
And even if we mess up, things
Life
will be
finds
okay.
a way to produce some kind of life. That's
Okay.
That's really what I'm saying. Nothing's going to make us. No, we're no. Any break in the branch in our ancestral tree, we don't exist. All right, but whole other vertebrates will exist, and other,
Yes. Yeah.
and dinosaurs are around for hundreds of millions of years, far longer than Homo sapiens have been around.
Yep.
So as far as they're concerned, they're quite successful.
Yes.
They didn't have a space program.
Yeah.
If they had, they would have deflected that asteroid.
Oh, yes. Without a doubt.
I want to keep open the possibility. We need not be the pinnacle of this evolutionary path.
I agree with that.
That other evolutionary paths might have been differently fertile, but had a different kind of Earth with different life forms.
That's very true, and I think this whole earlier depiction of evolution, like from monkeys to humans, maybe drew that picture in our minds that we think there's some direction to evolution when there isn't.
There's no direction at all.
So we think A became B, B became C, C became D, and then boop, we appeared.
And like I said, everything has evolved. Everything that's here now evolved. And we still have, but based on what you just said, we still do have dinosaurs. They're called birds. So
dinosaur descendants.
That's what I'm saying.
Yeah.
That's their evolution.
Yeah.
Right?
And I want to add something to something you said earlier. Earlier on, we mentioned, well, how long did it take life to show up on Earth? Because Earth formed in the void, and it's a hot thing.
And it's got a
So, life came around even faster than that, because we have a period in the early Earth, what we call the period of heavy bombardment, where the solar system is vacuuming up the remnants.
I know where this is going.
Okay, so we're being pummeled. But
because there's still a lot of trash out there floating around.
Correct. We're being pummeled. So the official word would be we're still accreting leftovers from the early solar system.
Gotcha.
My point is, you can take a thermometric measure of Earth, and Earth is way hotter than what would sustain complex molecules. So you wait for that to cool down, then you start the clock. If you do that, then life started here within 100 or 200 million years, not 500 million years. Faster than even, you don't start it when Earth began. You started when Earth could have possibly sustained a complex molecule.
Life. Gotcha.
Doesn't it help you out?
I mean, sure. Like I think I was referring to what we can track in the rock record, right? Using the isotopes and that. So we're really referring to some cell that already was doing its thing. I am not sure to what degree, based on our understanding of chemistry, yes, we do need some optimum temperature for certain complexity to emerge. But there's no reason for, again, early chemistry to also evolve from simplicity to chemistry. Chemistry can give rise to more. Complexity gives rise to more complexity. Machina ex machina, right? Like you can have that original messiness, and out of that messy chemistry, there's more messy things that came out.
So you're saying that the noise that is in the very beginning is part of the process itself, or could be.
I think so, but I think what Neil's pointing out is that what we think as life is different than life circa 100 million years past Earth's formation, right? But we think in biology, at least, or at least when we think about the last universal common ancestor, that's already a fully fledged, can eat, can poop, has all the genetics and doing its thing organism.
Sure. That's an organism.
But origin of life is different than that, right? So origin of life could be a complete chemical system that can maintain itself and do its thing. So there's likely some period.
So what did you guys?
I'm just saying that when you start the clock, you don't have to start it at the formation of Earth. That's all I'm saying.
You're saying start it at the place where it could happen. Where it could be
you want it to be
sustained.
where
it could be sustained.
Exactly.
Gotcha.
That's really all I'm saying.
So what was the thing that you guys found in your field that is the earliest form of an organism?
Well, in biological terms, it is 4 billion years. That's the latest time for this ancestor. That's the last universal common ancestor we look up. So the first organism. But keep in mind, we use what we refer to as phylogenetics, these trees, tree of lives. Obviously, there is no tree of life. It's our romanticized view of life that we collect everything. We drove trees and we imagine everyone.
You tell me there's no tree of life?
It's a thing.
Tell me that.
Sorry, but it helps.
I like
right?
trees of
Biologists
life.
like metaphors.
You take that from me?
I will take it. And I study trees.
She don't play.
I will leave this room with the tree.
Say something right now. You are cold-blooded, man. You are cold-blooded.
I'll take it. Where does...
I would like you to read me a bedtime story.
Where does the tree of life analogy fail?
Because it doesn't really factor into the genetic exchange between organisms. And I think it creates this
It
understanding.
implies a certain period of
Exactly.
path.
Yes, it gives this direction again. Time zero. Then it is likely more web, a network, rather than past tomorrow and Wednesday.
I'll give you that. Okay.
So it's more of a
Monday,
web than a tree.
Absolutely.
Yeah.
But it helps us, of course, because we understand time, we need to. But it is important that, we acknowledge that we made that up. Like, we just use that as a way to make sense of it.
Make it simple. Make it easier to understand.
Exactly.
That's all.
So, I want to bring some physics into this, if I may. So,
See, you made him uncomfortable. No, you were just like, there's too much damn biology. We gotta get back to something. Let's bring some physics into this.
I mean, if you made a pie chart of this show, it's probably like, what's the biology percentage?
No, we're trying to get some good biology on here.
Yeah.
No, we
don't
do.
mind.
You can have some physics, Neil.
Okay, let me just
Go for it.
Let me stir some physics into this.
Okay, go ahead.
If we were to define life in some way that might also apply on another planet, one of the concepts is metabolism. That the life absorbs, by whatever means, energy from its environment and uses that for its own survival and possibly reproduction. So how much do you guys think about metabolism when you think about life?
Oh, all the time.
All the
right?
time.
It's the engine. We take metabolism. I mean, it's just.
Okay, here's something else we think about. If an entire system is exactly at the same temperature, then you can't have a process take place. Because a process takes energy over here and puts it over there. And in order for that to be the case, it's got to be like hotter over here than over there, or things have to be moving over here more than they're moving over here. So when biologists explore the world and think about life, you also think about energy gradients from one section of an environment to another.
For sure. So we first of all, I mean, I'm a weird biologist because I'm interested in astrobiology.
No, that's the best kind of biologist. Go on.
But that still makes it weird. That doesn't get in the way. But so I think about the planet all the time.
Yeah.
But for sure, biologists think about the ladder in which a donor and an acceptor and how they relate to one another. And what gives, what takes, and what kind of voltage can be generated in exchange of electrons or materials in terms of like electrons, I guess, between the two ends of the optimum. So absolutely, because as I said, life is an electron looking for a place to rest.
Yeah.
It is all about precise channelization of these electrons.
Right, because
across
if
the
all
gradient.
electrons are already resting, nothing happens.
Exactly. So you need a receiver, you need that push and pull, and you need that tension, and you need that fight between these systems so that you create energy and you channel that, and you basically channelize that energy across enzymes or whatever is in the cell so that they bounce and push and pull and do their thing.
Okay, because we're looking now, we have a mission going to Europa. It's a ice penetrating radar mission that will orbit. So Europa has this ice sheet on top, and we're quite certain that there's highly confident, there's an ocean of liquid water. It's kept liquid from the tidal stresses of Jupiter itself. If it's just an ocean underneath ice, I guess it's kept warm because of the tidal stress, and maybe that's the source of energy.
That's the source of energy.
That's the source of energy for it.
Right.
Because without it, you would have no energy source.
I mean, even if it is dormant, we will still be able to find it if it is there, because we have like fermenters on this planet that are also quite lazy. Like what the voltage between the giver and receiver is pretty minimum. They're really weird.
Fermenters?
No, I mean, it is basically, if you're thinking about the ladder between the donor and the acceptor, fermenters, we want the ladder to be, if we draw a line between the donor and the receiver, we want that line to be as steep as possible. But when it comes to fermenters, you're getting almost a flat line. They're equal footing, but it still works. So even though
It's any
thermodynamically,
slope at all.
yeah, hardly any.
I had not thought about that.
Even though it is not, by looking at it, it's not energetically favorable, like maybe a carbon fixer might be, or photosynthesis might be doing. It is still doing its thing. So what I'm saying is that dormancy or that sort of slow process will not get in the way. We will take what we got. Let me get to Europa.
Whatever the slope
Whatever the
is.
slope is.
We're good
It's a
with
bunny
it.
slope, but we're taking it.
Right.
But yes, metabolism, absolutely important. It's the energy, it's the engine. It's all about the battery, right, when it comes to life on this planet. So
Okay,
we
so
have to
now,
think about that.
Those two, I'm happy as being the only criterion for life. But you speak to a pure biologist, not an astrobiologist, they start adding other things. Has to be susceptible to evolution.
Sure.
Has to be able to reproduce. Has to, and I'm thinking, really?
Really?
You think so? And how do you feel about these other criteria?
Absolutely. I mean, you cannot just have a battery that's just sitting there, right? The battery needs to produce another battery somehow.
Why?
Well, then it's not life. It's just sort of a battery.
Why can't it just be a
right?
battery that lives 1 billion years?
But then it's not life, though. What do you mean? How is it going to live?
Well, it lives slowly.
I was going to say, it lives until it runs out of juice.
It likely can assemble, but in order for at least our understanding of life, that memory of the information that assembled that metabolism per
Right,
se
it continues on.
It has to continue.
Right. So you're saying a bunch of logs laying in a pile is not a house. You got to actually have a house in order for it to be
not a house I want to live in.
Yeah, that's what I was about to say. Yeah, where's the bricks
Where's
and
the
mortar?
bricks and mortar?
Yeah, but I guess what I observe in the field also, I think there was some division between metabolism, or is it information, is it informatics, or do we need to replicate, or do we need to eat, right? And I think we are more merging right now that we need both. Like it's a problem that needs both ends. Not only you need metabolism, but also you need a way to transform that information of the presence of the metabolism to your offspring.
All right,
That's
so
when things
to
get
cap
tricky.
this between you two, for everybody listening, including me, can you give me, in a very succinct statement, what is life?
Life is a form of chemistry that maintained a memory over really long time periods. That's all I can say about life at this point.
Okay, that was very romantic.
Memory, like the corners
Some
of
good,
my
some bad.
mind.
But it retained it, right?
I got you. Yeah, okay.
If a space alien landed on Earth, walked up to you, and demanded that you take it to your leader, what would you do? Do you take the alien to the White House, the Vatican, to the UN? Where do you go? If it's got some appendage sticking out, do you reach out and grab it and shake it? I wouldn't. You don't know what part of the anatomy that is of the alien. It's all there. Take me to your leader. Perspectives on your first alien encounter. We like thinking that intelligence is important because humans are intelligent, but then I say, who said humans are intelligent?
It certainly ain't me.
We define ourselves
we
as
define
intelligent.
ourselves as
Yet
true.
we coexist in this world with cockroaches and highly viable life forms coexist with us and don't have anything of what we would call intelligence. So intelligence can't be all that important for survival. Otherwise, I think it would have shown up more in the tree of life than it has. So, but I've heard this term chemical intelligence. What is that? And how does that fit to what I just said, if at all?
Yeah, I mean, intelligence is an interesting term, especially these days, because what does that even mean,
Right.
So we attribute it to artificial intelligence. Like, what is that? What makes the artificial system intelligent? I guess we wanted to confront that with a new term, which is chemical intelligence. It's not artificial, it's not biological, but there's an underlying intelligence to life. At the heart of life and its emergence, we think that these reactions that we talked about, that complex systems, they're probably coupled to one another, right? You're not looking at a complex carbon fixation metabolism, right? These are very big. It's like it's a crowded place in the cell. Everyone is reacting with one another. But early on, we think that there were these cycles coupled to one another. So they produce a waste, that's a chemical, and another cycle takes it, rotates it, spits out. There's input and output constantly. And that is really probably the most fundamental form of metabolism.
So it's a chemical factory
in a way.
In a sense.
Sure. I mean, life is in a way too,
Yeah.
but you can also simplify it in the basic form that we like to refer to them as autocatalytic. So they've been able to catalyze their own presence.
Autocatalytic.
Yes.
Yes.
That's you said it better than my autocatalytic. I gotta do a lot of like.
Okay, now we even because I couldn't pronounce your name. Perfectly.
Okay, that's not fair. I should be saying.
And I like the way you say it like you're from Brooklyn. Out of catalytic.
Yeah, the hand was in that, the hand gesture. So I have a fast story that happened to me 30 years ago.
Okay.
The astronomical community had discovered this possible signs of life on a meteorite that is from Mars. Okay, the famous Allen Hills meteorite. Back in 1996 it was, I think it was. I'm on a TV show with a biologist, okay, discussing this result. And they had this scanning electron microscope photo of something that looked like a little worm thing. Very small, like 1/10 the size of the smallest cells on Earth. Okay, really small. And it needed an electron microscope to see it. Okay, we're exploring what is this evidence on this rock. There's like organic molecules. And it's tantalizing evidence. The biologist, upon seeing this little wormy thing, said, "That can't possibly be life." And then I thought, wow, he's really certain about this. There's nothing I'm certain about in the universe that I would utter with that level of confidence, okay? But he's certain about this. And I said, why? And then he said, because that's a fraction the size of the smallest life on Earth. And I said, last I checked, the rock is from Mars! universe. Okay, so why are you a biologist but stuck with only one kind of life, passing that kind of judgment on what could be life on another planet?
The first, well, it's amazing that you were in that room, first of all. That's pretty cool. The second, though, is that we know now that the size is not necessarily a determinant of life forms. They're based, like ribosome itself, the presence of a ribosome, I will argue, would be life, right? Like, so it has to come together through biology. So size itself is not what I would go after if I were to first criticize that sort of finding. So no, size alone isn't. We know this, and that's the beauty, I think, about space exploration, is that we learn so much about what are the limits of life and what life is. Is it something that I know when I see, or is it something that I can attribute to size? Is it just some chemicals? Is it some sort of movement? Like, what is it exactly?
Because that affected, let me just call it a bias.
Right.
When we first landed on Mars, we performed tests with Viking lander. We have our own bias, life
Of
as we know it.
what we're looking for. Right.
Yeah, and if something's there that you're not looking for,
Right.
will you find it?
Right. Especially if you have a preconceived notion of what it
If you
should
preconceive
be.
of what it should
And
be.
we
I'm
learn
just
so
happy
much.
that the universe has confirmed that size does not matter.
Not only that study, of course, led to a realization that we need experts that can combine or look into some biological process on a rock and interpret it, right?
Yes.
We didn't have that kind of understanding, so we gotta be a little bit gentle, I think, with what we know now. Far more suppresses than what we thought life how it can express itself.
An informed biologist, and certainly not you, would have reacted that way in that conversation.
I wouldn't go after, whether there could be smaller life forms
Right.
than what they're saying, but nevertheless, there are obvious. Now we can do more. We can look at isotopes. We can understand to what degree. It is actually so crazy. I mean, think about the sugar molecule or caffeine. Some people have models with the caffeine molecule in it, right? We can understand each atom and the discrimination of each atom, their discriminative properties of the atmospheric isotopes. But we can atomically explore each atom
Yeah.
in a
It's
complex
a
sugar
beautiful thing.
molecule, through the clumped isotope methodology, and
Yes.
we can attribute whether that value is coming from a biological system or none. That is so insane to me. I mean, there are
Yeah.
very few people on the world that can do this really well. It's very easy to mess this up, so I respect to them. But we can identify if it is just an amino acid on an asteroid versus a microbe that or a once living microbe. So we can do these sophisticated studies, and we are getting there now with the sample return, right? With the Bennu. Like, it's just so much happening. And in fact, it was today a paper came out. I was reading it on the way here that took Deinococcus, this really resistant crazy bug that can survive under really harsh conditions, and radiated and it put this insane amount of pressure on it to understand whether this bug can survive planetary travel. And they found that it can, at least numerically, it can handle really, really high pressure. So that's kind
That's
of
the
amazing.
panspermia hypothesis.
Exactly.
Yeah.
I mean, they're kind of linking it to that as well, very carefully, because that one line of data doesn't make an entire concept, doesn't prove the whole thing.
Right, of course.
But it is fun to think about it.
Yeah. Well, to dream about all the ways of being alive. And so what about the science fiction writer's best friend is thinking about silicon-based life? Swapping silicon in for carbon every place you find it. Because they have the same outer electron configurations, so you can make all the same molecules.
Well, protein engineers showed this about 7 years ago. A paper came out that showed that in an enzyme they could replace the carbon with silicon. So at least engineering-wise, we demonstrated that you can, to some degree, push an enzyme to use silicon instead of carbon.
And still have the same function it did before?
Yes, albeit with some variations in the sense of it's not maybe as efficient, but it's fine.
Sure.
So, but in whole organism, look, nobody wants weird, strange life forms more than me. Okay? But I also want to be able to study something and not hallucinate, right?
Right.
There's a part like imagination is great, but then you got to be, I think, a little careful and not go a little.
Go too
alien
far.
hallucinations can be a little too much.
Go too far.
Exactly. So we got to start with what we know, and especially understand that we know very little. We know less than we think we do.
That's always true at all times. For everyone.
Except me, I'm sorry. You want to know about life?
My rebuttal to the silicon-based life versus carbon-based life, just as an astrophysicist, is that there's at least 5 times as much carbon in the universe as silicon.
Well, that kind of goes back to the beginning of our
So you don't need to appeal to
discussion. You don't
silicon.
need to do it.
Carbon's
Because carbon's too available.
It's too available.
Yeah, it's too available.
It's very
Yeah, it's like-
fertile in the chemistry lab.
And it's like you say, whatever the easiest way, life is lazy.
But if you think about it, life also relies on all these rare elements and metals on this planet that is nothing for the universe. It looks like it's just a waste, right? It's something that you would not even consider as fat of the steak. You know what I mean? It's just like, sure, take it, and then look what life did.
Yeah, so that's being opportunistic, perhaps.
That's inspirational. That, you know, again, it will assemble this insane. Look at us. Look at the world. It will come out of like almost out of nothing for the planet, for the universe.
Right.
And that's what we study with the NASA Center MUSE, the Metal Utilization Center.
Yeah, tell me about that.
We're trying to understand how the oceanic content across billions of years have inspired organisms to do their thing. We want to know how they competed against a certain metal. Life is metal, right? Life relies on metals. Enzymes do their thing. They are able to do all these crazy thermodynamic barrier breakings because they eat a lot of metal. They depend on this. And metal has to come from somewhere.
When you say metal, I mean iron,
Iron,
calcium.
we're interested in molybdenum.
Well, calcium, I mean, astrophysically, everything that's not hydrogen or helium,
Exactly.
we call metal.
Oh,
It's stupid, but it's
Okay.
left over from the old days.
forget it. After that, you're done.
But look at this feast life created with all the leftovers.
And with the
Right,
leftovers.
exactly.
Right, think about it. 98% of the universe is hydrogen and helium.
Right.
Everything of interest to us is with the 2% that's left over.
Exactly,
Right.
and we know it's a very iron-rich planet, right, early on.
Yeah.
And then with oxygen, what happens? What happens with oxygen?
And iron, you get rust.
Exactly. So you're fried, and we see that in the rock records. Like
Yeah.
we can. That's how also we understand that our planet has gone through such revolution.
These are these layers of iron deposits.
Iron
in,
deposits.
Yeah.
Exactly. So they,
And
they
that's
are
life generated. iron.
Exactly.
Yes, it's not an iron ore coming through. It's the
It's
iron
life
left
generating.
over.
And
Yeah.
it is, and by the way, that knowledge is also only like 30, 40 years old, right?
Wow.
Like we did not know that microbes are able to leave a mark behind.
In fact, when we opened the Rose Center, that was new information. And we made a very big deal of that in our exhibits to date back the earliest possible life.
Yes. And it
Nice.
comes back to a study from University of Wisconsin-Madison.
Oh,
I gotta mention
Somebody's
that.
tooting their own horn, I see.
gotta give the
I
credit
got
to
that
Stanley
figure
Tyler.
action too.
Stanley Tyler,
Yes.
as he was doing, what a good geologist does, FA and FO. And he was just hiking around, and he came across with these iron deposits, some rock formations that are different than the others, near Gunflint Church, which is in the Canadian border. And he wanted to understand this, and he collaborates with a scientist at MIT, and they are able to do all kinds of basically relying on the radiation technology, not only date the rock, but understand that there's a microbe here. Which completely transforms our understanding, because if you think about it, and going back to Darwin, even he contemplated about origin of life in the past, just maybe once or twice, some warm little pond, whatever. But his biggest dilemma was that if everything comes from an ancestor, where is the ancestor of the ancestor? You fall off a cliff once you pass Cambrian. Like there's all these, Ediacaran things and footsteps and, like bones and whatever. Bones are late, but
That's post-Cambrian explosion.
Exactly. So
And before it, you got nothing.
you got nothing. So a lot of people were also at that time. There's all these intense letters to Darwin saying, "How do you explain what happens?" Because there's a gap, right? There's this huge gap. And through these studies that are only 30, 40 years old, we now know that entire 4 billion period was microbial. And now we are able to go to a rock and atomically process it and understand that those colors are generated due to once living microbe. Insane.
Yes.
And it is red because there was oxygen on the planet and they liked iron, but boo-hoo, so bad. It's a catastrophe because now there's oxygen on the planet and you're gone.
Yes.
So what we are interested in understanding is that how that shift, the presence of oxygen, transforms organisms and entire life on this planet.
I'm just glad I am on the side of the biology fence where I can metabolize oxygen rather than have it
Kill you.
Kill me.
Right.
Yes.
Exactly.
Have me be like melting like the Wicked Witch of the West. It's like, oxygen, I'm melting. So something I'd missed. What is it that we do today to create the nitrogen necessary to infuse into our our
Very good
agriculture?
problem. There are two ways. One is coming from biology, and that's biological nitrogen fixation. And we also have the Haber-Bosch process.
And how does that work?
It's a very energetically expansive process. It not only obviously uses nitrogen, but also hydrogen. And in the presence of a catalyst and really high pressure, produces ammonia.
Nitrogen is just in the air.
Yeah,
right?
nitrogen's always in the air, but
Right.
it's not readily available. So we do
Free nitrogen is not available for you.
in the form that is that is useful for biology. So it
Right,
needs
right.
to be converted into ammonia.
Okay, so now you got ammonia, now what?
Now
You got clean floors. So what do you?
well, we need it for fertilizers,
Right,
so that's
okay.
where they go primarily. And but say for example, or cereal or corns, they use biological nitrogen fixation primarily.
Because when you farm, that's what comes out of the soil.
Exactly.
It's the nitrogen that comes out of the soil. So this allows you to re-energize or replace the nitrogen in the soil.
I think what is really interesting here is that as we read more about our past, as I understood more what our planet has gone through, and when you connect biology and molecules to the planet, which is something we have to do if we are serious about finding life.
Right.
Because even though we are making our observations at these large scales, ultimately we are looking at an expression of something really, really, really tiny. Instead, that's the molecule. So we need to be able to connect molecules to a planet, ultimately.
Yeah. Otherwise, what?
Exactly, but that bridge was missing. So I think our research fills that gap through the planetary biology concept. And what we are understanding is that just because something isn't around doesn't mean it was useless. And that our planet has gone through things that actually could teach us a lot about the future because they resemble our future.
And resurrecting tools of the past
Exactly.
to shape our future.
Nice. Ooh, lovely.
So, is your lab funded by NSF or?
We definitely had support from NSF, NASA for
Not
sure.
for long. If it's up to me, I'm just saying. Quite frankly, I need the money to start more wars.
So,
The John Templeton Foundation was
Okay.
very generous with us,
They
as well
came
as
in,
the
yes.
as well as the Keck Foundation,
Mm-hmm.
and also the Hypothesis Fund that they've been really
that's new to me.
generous.
Hypothesis Fund.
Yeah, they sort of it's
Good
called
name for a
Cool
fund.
name.
Nimble funding for nimble minds. I think is that. So I got a cold call one day saying, if we give you this much money, what would you do with it? And I'm glad you asked because I have all these ideas. And this is the whole idea of. They said, okay, great, but no respect to elders. If what can this do for me? Or give me like what is your sort of moonshot experiment? And I said, well, I think there's a lot we can learn from the past for our future. And so they invested in this work, and then later Keck Foundation supported it, and that's our primary funding right now. So
And Keck, of course, funded our twin telescopes in Hawaii.
Wow.
The Keck Observatory. So I'm delighted to learn of this. I'm more delighted to learn that your work is visible enough to attract cold calls
Yeah,
from
man.
funders. That's
serious.
That's serious stuff.
Ain't
right
nobody
there.
ever called me to offer me some money. Just letting you know, that's when you know you're doing something right. When they call you, I'm like, do you need some money? Like to give you some money. Like, that's when you know you are kicking ass.
I thought it was a joke because it was my birthday.
Oh.
So I thought, who's this? And that's not funny, but then it was real.
That's great.
Wow.
I had to write a proposal, of course, but it was an invitation to.
Just congratulations on this. And
Congratulations.
it sounds like it's very fast moving. Be delighted to catch up with you again when you got more enzymes and we'll find out just how different our future is going to be.
Yeah. Well,
Working
just
on
make
it.
some enzymes and we'll talk about those.
Oh, that would be great. So you're working on it. You bet. You're on it.
Yeah, I want to find out in what way your professional work will influence the future of civilization.
And if you want to give the number to the lab, maybe there's somebody out there that might want to give some money.
How do we find you on social? Are you active on social media?
I am on Instagram. Yeah, I used to be on Twitter. Now it's X. I'm still there. I have the account.
Okay.
Yeah, they can for sure find me
Instagram,
there.
and what do you call on Instagram?
My really hard to say first and last name .astro.
.astro.
Bitul dot.
Kachar. .astro.
There you go.
bitulkachar.astro. I finally got it
Yes,
right.
yes.
Excellent.
Great.
Very excellent. Well, thank you for joining us
Thanks for having me. This was great.
on Star Talk. It clarified some confusions I had and brings a whole field of study into the attention of our highly scientifically curious audience.
Yes.
Thank you for having me, and I hope we realize that past is not something to be feared, only to be understood, as Mary Curie said.
You don't know my past, people. I'm just letting you know.
Hey, you don't know mine either. Okay.
This has been another installment of Star Talk. Well, thanking my guest, Bitul Kachar from University of Wisconsin-Madison for sharing her expertise, her wisdom, and insight on life yesterday, today, and tomorrow.
Ooh, look at that.
Here and there. Got both dimensions going.
Sounds like a soap opera.
Chuck, always good to have you, man.
Always a pleasure.
Until next time, as always, keep looking up. Let's go back to the Mars Climate Orbiter, where it never got into orbit because the scientists were using metric and you engineers were still on imperial units. What's up with that?
What's up with that is we've carried mixed units in the United States for way too long.
Be blaming the country. All right, blame it. You're the engineering people. You know you're talking to scientists.
Did that scenario cause them to make the change? Or are they still being dumbasses?
I think, Chuck, there's still pockets of dumbassery going on.
This is Star Talk. Neil deGrasse Tyson, your personal astrophysicist. I got Chuck Nice with me. Chuck, baby, how you doing?
Hey, Neil, what's happening?
All right. We got a good show today. Oh, my God.
What's on
With
tap?
the future of the space industry.
Oh, and you say that's a good show?
Oh, yeah. Oh, yeah.
You think there's a good future for the space industry?
You want to get off this earth? You better think it's good.
Okay. Well, you know, I do want to get off this earth. I'm just afraid of who might be driving.
Oh, there you go. There you go. Did I tell you? People say, you want to go into space? You want to go in this guy's rocket and Bezos' rocket? I said, yeah, but I want him to fly his mother first.
Nice.
And then I'm cool.
Right, then I'm cool.
Then maybe I'll step on the ship. So I love this field.
Okay.
But I have no specific engineering expertise.
All right.
So we combed the land.
Yes.
To find somebody who's been in and out, and in that whole field.
Oh, right on.
And we got a man right here.
Yes.
He right here, sitting right here. Sir.
Neil.
Welcome to Star Talk. Jeff, did I pronounce your last name correctly? Thornburg.
That's correct.
There you go.
Yeah.
Jeff Thornburg.
There was a very popular, nighttime soap opera called The Thornburgs.
Thornbirds.
Oh. Yes. Well,
Slightly off.
as you can tell, I was a huge fan of the show.
You would be surprised, Chuck, how many kids in school equated Thornbirds with Thornburg. So you're in great company. You're in great company.
You should be embarrassed that you corrected someone on a soap opera name. What else do you do? Is that what you're doing during the daytime when you should be building rockets?
Yeah, well, everybody has a side hustle.
Very good.
So you are currently CEO of Portal Space Systems.
Yes, sir.
I love that.
That's very
Aerospace engineer.
Nice.
We need more of those.
Yeah.
And you have a background with the Air Force. That might have been the Space Force if it had been now. NASA Aerojet.
Yes.
Love Aerojet. SpaceX and more. So you've been around.
I've been around.
But it sounds like you can't hold down a job.
Yeah, well.
What's the difference between everyone wanting you and everyone firing you?
He's like, don't shame my success with this drinking problem.
What's the difference?
Look at the success I have achieved, all while holding down the drinking problem.
My best answer to that, Neil, is I grew up like I think you and others did, and aspired for this science fiction world that we all would like to see. And I would go work at these places and be like, not moving fast enough, not moving fast enough, not moving fast enough.
Very cool.
And so.
And then you decided to take it in your own hands.
Yes, sir.
Nice.
Ooh. That's audacious.
I love that.
No, it's bodacious.
I have a very loving wife who has been very patient with my 30-year
That
career as
definitely,
well.
you need one of those in that situation.
Yeah, I need one of those.
Tell me, what is Portal Space System and why that's different from what you've seen before?
Portal is building the most rapidly maneuverable spacecraft that's ever been built. And that's important because we're doing it with a lot of payload flexibility. So what that means is we can accomplish a lot of missions for defense and commercial customers. We can do it with speed. The problem with movement on space is you can't get anywhere very fast right now, especially with satellites and defense systems. So I got frustrated and I said, this is a solvable engineering problem. Why aren't we doing more about it? Okay, if no one's going to do anything about it, I'm going to go do something about it.
And engineers just love problems.
They do. They do. And they love developing new types of spacecraft.
So when you say get somewhere faster, you want to get to 9 months is not fast enough for you to get to Mars.
No, I want to do, no, absolutely not.
Okay.
Look at that.
So I think my vision, my long-term vision is nuclear thermal propulsion, I think, is a key thing in my lifetime.
As would be, that's anyone.
Sure.
You dreamt that last
Are
night.
you kidding me? That's how I came in this world. My first words after they slapped me on my ass was, when are we getting to nuclear thermal propulsion?
Thank you, Chuck. Exactly. That's what I've been saying for years now.
Wait, so you're talking about how nimble can you be in the 3D space environment?
Yeah, so our current spacecraft platform can move from mid-Earth orbit to low Earth orbit in less than 3 hours. It can move from mid-Earth orbit to GEO in less than a day. It can go from low Earth orbit to geostationary orbit in a day. So those types of
That's not fast enough for you?
That is fast enough for me.
Good.
It's just not possible with frequency now, unless you're using a rocket to do it.
It's not a routine thing.
It's not a routine thing.
Right, okay. So you're like, I'm going to turn commercial space into trucking.
No. Could you have more romantic terms than that?
No, but because like that's like very understandable.
He's going to be the Amazon of delivery system of space?
Or the
because like
FedEx.
Yeah. FedEx?
At one point, once we had containers coming in and container shipping, like the trucking industry boomed because somebody had to figure out a way to get these containers where they had to go, and quickly. And so, like, you're doing that, which is
our customers don't care about how cool the tech is.
Right.
They just want
speed.
They want it now. If there's something going on in the world they need to be looking after, they want it do it now. If they've got a spacecraft in trouble, they want to see it now. They don't want to agonize over, well, if I move it, maybe I'll never get to move this spacecraft again because it doesn't have enough.
I didn't even know that was a problem until you just said it right now. And let me not even think of it as a problem. Let me think of it as an unrealized need that you are fulfilling. Very nice.
That's right.
So we'll get back to that, but tell me, because you had your whole life is in this, and we're probably about the same age, so I'm feeling your enthusiasm and your disappointments with what we've seen out there.
My long-lost brother in space. Yes, I'm feeling that.
So what are some things that you have worked on that you could tell us about?
One of the most exciting projects I got was when I was a young engineer with the Air Force Research Lab, and I got to develop a brand new type of rocket engine called a full flow stage combustion engine. That's a fancy name for saying the highest performing rocket engine ever made.
And just to be clear, Air Force Research Lab, that's not just another lab on the street corner. That's an FFRDC, if I remember correctly, or not?
It's a government lab.
Okay.
There are contractors like aerospace that support in an FFRDC way.
What does that mean, please? FFRDC.
Federal funded.
Stay with us, Chuck.
Yeah. Trying to keep up here, but you guys are like rocketing off.
Federally funded research and development operation.
Okay.
Where it's a way for the government to get a piece of a pie that's being baked that corporations wouldn't otherwise do because it's a little risky. It's a little kind of off the thing, but
no business case, no profit margin.
I'm doing that now with NVIDIA.
Okay.
Right. So I got to work on that rocket engine program, and it formed a kernel of several kernels of technology that seeded the propulsion industry for years to come. So I got to work on that program between 1999 and 2004. And then that seeded engine programs like J2X that were part of the Ares rocket program. It seeded things like what Stoke is doing with their full flow engine. It seeded what I did with Raptor later on at SpaceX, because I developed and architected the Raptor engine system for Starship.
So when SpaceX rose up out of the din of rocket corporations, were you cherry-picked? Did they cherry-pick you from your previous location?
I don't know that I ever got the full story, but this is a true story, is that Elon called me at home in Huntsville and said, I got a project I think you might be interested in.
So that counts as being cherry-picked, I would say.
I think so.
Yeah, when the guy who owns the thing calls you personally, he's stealing you.
So shortly after I left NASA in Huntsville and went to SpaceX.
It's Huntsville, Alabama.
Huntsville, Alabama.
And of course, we just learned that the headquarters for the Space Force is moving from Colorado Springs to Huntsville, Alabama. It was a little weird because the president said, and from now on will be named Rocket City, but it's always called Rocket City.
Yeah,
Always been Rocket City.
It's always
Well,
been Rocket
he
City.
does that. Let me ask you both this then, before I know, because you brought up these FFRDC.
Yeah.
Is that still necessary now that there's so much commercial activity in space travel? And is it still necessary for the government to seed money into things so that we can then go forward in discovery?
I love your question because what I've been watching happening in the quote new space industry is venture capital and businesses chase things that add value or add to the stock price or add to profit. The government and the FFRDCs focus on necessary technology that there's no business case for. So
No business case at the time they're funding it.
Okay.
Who knows what'll happen after?
So I feel that FFRDC should definitely be seeding new technologies like the ones we're developing at Portal for this rapid movement, because no one else is going to do it. So NASA and the Air Force have done a great job over the years of developing technology that then they later put next to the Ark of the Covenant in the warehouse at the end of Raiders of the Lost Ark. And I've been fortunate enough on a few different occasions to go back into the warehouse and pull some of these things that the government has developed.
It's so beautiful.
Yeah.
That's excellent.
So, yes, I think the need is definitely there. And when
And your face didn't melt when
My
you
face didn't melt,
reopened
no.
the Ark.
But when I was in the Air Force specifically, one of the biggest issues is that nobody has that foresight to know all of the ways the technology will be applied.
Right.
And that's why
Nobody has that.
Right. That's why it's so important to keep the government involved in pushing that boundary. And I think that's where the government should be spending their money. Unfortunately, those government budgets are shrinking because I think some people think, well, private industry is just going to do it, so why do we have to fund it anymore? But what they don't understand is VCs and private industry are chasing value creation and stock price and profit, and that may not be in the same wheelhouse as the technologies we need to actually get humans to Mars, to get humans to the moon, and to explore the solar system.
Yeah.
And that's where China enters the picture.
Then there was China.
And then there was China.
So tell me about Aerojet. What'd you do there?
I worked as an engineering manager and director on liquid rocket engine technology development, did a lot of turbo pump development for liquid rocket engines while I was there.
What? I mean, we've had liquid fuel forever. I mean, since Goddard, right? So what new thing was necessary?
Getting weight out of the system.
Oh, every ounce matters.
Every ounce matters. And combining components, bringing in technologies like additive manufacturing to reduce part count.
Wow.
And figure out how to qualify systems to do that.
If you reduce part count,
Yes.
that reduces the error, the points of failure.
Correct. Right.
That could take place.
Reliability goes up as part count goes down.
Because I remember when the shuttle first came out, okay?
Yeah.
And there was this headline that sounded like it was bragging, and I said, that's not a brag. It said, the space shuttle, it's the most complex rocket ever to be launched. And it's like, you don't want that.
Yeah, right.
But am I right? I mean, you're the
correct.
engineer.
Yes.
It's like, don't tell me that.
Well, in fact, they couldn't reuse it the way they wanted to because of that fact. You know, shuttles were going to launch 25 times.
Yes, every couple of weeks.
Every couple of weeks. And then they're like, oh, these engines aren't as easy to refurbish as we thought. We've actually have to rebuild them after every flight. Oh, we got wiring issues that we hadn't accounted for. Oh, we've got
Okay, so
tiles.
Tiles, right, that'll fall off.
Right.
So when the shuttle was retired, we didn't have a way to get to space.
Yes.
And so I guess we used with Russia. I mean, they were our friends back then. Who knows what they are today? But they had the Soyuz capsule, Does the Soyuz have like 10 parts to it or something? It's kind of a blunt instrument that works every single time. Tell me about the Soyuz.
Well, the Russian...
And you testified about that, so catch me up on that.
I mean, the Russian development of rocket technology is interesting because you have to go all the way back to the end of World War II. We cherry-picked rocket scientists. The U.S. grabbed their lot, including von Braun.
Werner von Braun, yeah.
Russians grabbed their lot. And what happened was the Russian lot of German rocket scientists really ended up focusing on reliability and part count and manufacturability. Von Braun and his team, and what later became the bulk of NASA, focused on performance and perfection. And so there was two completely different thought processes between Russian rocketry and American rocketry at that point that can trace themselves all the way back to the end of the Cold War.
And that persisted. And so to this day, the Soyuz, isn't it the most reliable?
It is, and it has heritage dating all the way back to the 50s because they've never changed it. And there's
so it's still got a compass. Or in the Flintstones, you look at the legs are running underneath.
And I mean, and their technology, there was so much elegance in their manufacturing that we ended up buying a lot of their engines at the end of the Cold War because we didn't want the Russian rocket scientists going to Iran and North Korea and other places.
That was part of our relationship with the space station to bring them on, give them something to do. In the day, everything that NASA launched said NASA on it, even if it was built by Boeing or Lockheed Martin or whoever else. But private enterprise is now putting things on the shelf that NASA then selects off the shelf, and that all has the name of the companies on it.
Yes.
So this is a shift. Could you take us through that shift?
Sure.
From the old days into what's actually happening now?
Yeah. So about the time, the early 2000s is when Blue Origin and SpaceX were incorporated. And then over the next 10 years, they started to develop capabilities to launch things that were interesting to NASA. When I was at SpaceX, and we were developing Falcon 9, they didn't believe that we could do those things at those price points. So they kind of patted us on the head and said, that's cute, let us know when it works. And then it did work. And then that's when the real interest came forward, because now for $60 million a launch, you could do a lot of cool things that you couldn't do with the Space Shuttle program. And then the race was on.
Space Shuttle was $1 billion a launch or something?
Something
it
like
turned
that.
out huge.
Moly.
Yeah, part of it was because there weren't as many launches in a year to amortize the cost of the marching army to keep all that going. And with more launches, then the less per launch the effective cost is. But if you bring the cost down to that, that's another ball game.
It's a whole other ball game. And that's what got us excited about the shuttle retiring, because the race was on to get Dragon on a Falcon 9 as fast as possible and get astronauts to the station and get American astronauts again to orbit. And we put all the NASA logos and everything, and they were a great partner and all that. But, it was weird because people would come up to us and say, does NASA exist anymore? Because SpaceX seems to be launching everything.
So let's get the animal straight here. So the Dragon is the capsule.
Correct.
The Falcon 9 or the Falcon Heavy. The Falcon is the rocket, the launch system.
First and second
stages of the system. Good. Just get the animal. If you were,
yes.
Were you up with the animals there?
Yeah. We didn't we go to SpaceX and I think you said it's the number of.
Well, it looked like it. Is it true? The Falcon 9 has 9 engines on the bottom.
That's correct.
Okay, because we visited the headquarters and
nice.
Yeah, it was one. The Star Talk goes to SpaceX.
Yes,
I think it's online.
Yes,
and we were just chilling and looking at the rocket, and it's the one it's the first stage that comes back.
Correct.
Right, and you see it with the tripod.
Yep,
a big one mounted outside.
And we had to put that engine in the center to help facilitate the landing burn.
Right.
Let me ask you that. Let me ask you, if you're going to bring the stage back, that means you are using weight for fuel to guide the thing back for a soft landing. But I want that weight for my payload. So where do you, as an engineer, where do those two lines cross?
So the elegance in the engineering is that Falcon 9, basically, we actually pushed that vehicle to its absolute limit before anybody ever saw it do its thing. And we did that because we didn't want any excess fuel on that vehicle when it landed back. So Then what we did, the company did, the business people did, is they said, look, we're going to sell you an expendable stage or a reusable stage. And if you do the reusable, you'll save some money.
Oh, so then the buyer makes that decision.
That's right. Then the market,
That's brilliant.
The market chooses.
Brilliant,
And
brilliant.
What did the market choose? They chose the reusable version because it made the most financial sense.
Wow.
But so there's two things. There's a business
I'm
model.
glad to hear that. That puts
Yeah.
a lot in context for me.
Right. As an engineer, I have to make that system as efficient as possible, meaning there should be no unused fuel when it lands, and then let the buyer and the market choose that configuration because it makes the most financial sense, and then everybody wins.
Occasionally, you need the payload, which, if memory serves, they needed that extra weight for the Europa Clipper mission. I think the first stage did not return smoothly. That,
I think
that got dropped into
that's
the ocean.
right.
They needed that.
You got to have all the Delta V available to go to Europa. So,
Okay.
yeah.
Yeah, Europa, the Jupiter's moon.
Right.
Yeah, the Europa Clipper will loop around,
Yes.
make radar measurements beneath
And
the
they'll
ice.
sell that, but I think the business case people should understand is if you buy an expendable version, now that hardware can never be used again, and there's value associated with that hardware, so you're going to pay to basically use it all in one shot. And so that's another way to drive market value that's a good business case as well.
So, at the risk of asking the obvious, all these places you've worked, presumably there's a lot of wisdom you have gleaned from that you bring to your current job. Is that a fair statement?
I've seen a lot. Yes, I think that's a fair statement. That's
Yeah.
definitely true. But I think
You've seen the mountaintop.
I think more importantly though is I got to work with these graybeards at NASA and the Air Force. I got to work with some great people in industry.
Did you say gray beards?
Graybeards? Yes.
Do they have beards in the Air Force? I thought they make you shave.
Yeah, well, the civil servants have beards.
Okay. That's a pretty lax military if they're walking around with a
So
beard.
I tried to be a very good student of those older folks that had seen a lot more things than I had in my career. So
Give us a minute. We don't always have engineers on the show. It's mostly scientists. And for what it's worth, anytime people say to me, you guys are doing great things in space, I say, look, we know what we want to do, but we don't know how to build the stuff. There are engineers who you never come interview who enabled the James Webb Space Telescope, who enabled the Hubble telescope. And so I just want to, on record, give a shout out to nameless engineers who make the
responsible
scientists
for the success of everything.
of everything and make the scientists look good, but you only see the scientists get interviewed because they're talking about the results of the experiment.
right.
And whereas the engineer is not in that loop. So
I think that's awesome that you're doing that. And two, that's the best part of my job. Is like I know engineers that got degrees that never really became engineers because they never got to actually experience an idea that you actually have to go build that needs to work. And then I work with people every day, some of which that don't understand that engineering is sometimes an art form because you don't know all the things. You have to design around the uncertainty. Like, if you came to me with a new spacecraft system, I'd say, yeah, that's theoretically possible. Now let's go see what we can actually build and how accurate I could build it.
like a warp drive.
Right. We can totally work on that, Neil.
Yeah, what are you doing here? Get back to work on that. So
So you guys are like the workman that comes in your home, the contractor, and he's like, yeah, we're not going to know anything until we open up these walls.
I do have...
Gotta tell you, could be a lot of problems back there. I mean, this could be a $200 job or it could be a $20,000 job. We don't know.
That sounds just like my engineers when I'm pricing a program out. So you're hitting it right on the head.
So I just want to highlight for our audience, which is primarily a science-leaning audience rather than engineering-leaning, tell me the value of failure. Let's just start there.
I'll answer that with a quick story, which is a lot of legacy government and NASA programs have this failure is not an option moniker to them. And what that means is to have infinitely low risk requires infinitely high cost. And so that's not how a lot of commercial startups and businesses have formed in the last decade or so, because instead there's a different approach in engineering where we want to actually break it, because we want to see where the design fails and what we don't know yet and what we need to fix. And I think a lot of the legacy NASA programs have suffered at times because they've had to try to get everything right on the first go, and that's a pretty tall order. That's why these aerospace programs have taken so much longer than anybody ever wanted from a schedule-wise or from a cost standpoint. So I think
Elon in the early days was very visible with his rocket failures.
Yes.
And he made a very important point at every turn. We're going to learn something from this. Although it sounded a little too euphemistic at times, where the rocket blows up and it's, no, that was not a failure. That was an experiment rich in data.
Yeah. and it's true to a certain extent, but not all failures are planned, and most of them aren't. And but the value is if your company or organizational culture accepts failure, then you will actually get to the end product much faster.
There it is right there. That's it.
But also it's kind of a public perception problem for NASA, because there's never been a movie made about SpaceX or Elon Musk, but the whole idea behind the whole Apollo missions and everything that NASA does is triumph. We did it. And then the one time something goes wrong, it's global headlines of how badly they failed and what an incredible tragedy it is.
Right.
If NASA blew up 100 rockets, there'd be no more tax dollars going to NASA, whereas Elon Musk can blow up as many rockets as he wants.
Yeah, but as Neil knows as well, look at the history of the Mercury Gemini Apollo program. We blew up a ton of stuff.
Yeah.
Those young men and women were in their 20s. They looked like SpaceX looked a few years ago.
Wow.
And so NASA used to operate exactly in that mold, but somewhere along the way, politics took over and it got different for them. So I think NASA should focus on the programs that aren't viable as a business, that are pushing technology forward, because I think that's what they do really well at. I don't think they do well in big rocket programs. I mean,
Well, this is my reply. I'm asked it often, as you can imagine. We said it earlier. With private enterprise coming in, why do we need NASA? Because there are things that private enterprise would never engage on the frontier, where there's either risk that they would not take or return on investment that does not exist.
Not make.
Right, exactly.
And I don't think nation states should rely on CEOs to be their only hope in achieving certain national goals. I just think that's a bad idea.
Yeah, I wonder where I kind of agree.
Could be wrong.
I agree with you there.
That's just one person's opinion.
Yeah, when a leader of a nation breaks up with the CEO, like it can get ugly. You know what I mean? Like, who gets the cat? Like,
So you want people to be more comfortable with failure, because that's how you proceed. Not failure from blunder, but failure from something you had not seen coming. It's a different kind of failure, right?
I think people think engineers just know, and therefore when we fail, we're stupid or we're a bad engineer. And they don't understand the art of engineering is designing a system around unknowns, and that we don't always know the first time it's going to be successful. So I think
Which would include the unknown unknowns.
Correct. I think that's the unlock for people to know failure is a good thing, because you've now given engineers a gift, because now they have all of the information. So that's why failure is so important to engineering, because now you've pushed the design all the way up to the line. You don't have to guess about it anymore. So now you've gone from that initial phase of engineering around the markers you don't know, which normally means it's heavier or carries more fuel or less efficient in some way, because you're just trying to get it to work. And when you fail it, now you can totally isolate that to what it needs to be. And that's why things like the Falcon 9 first stage land the way they do. Because we failed so many of those, as the gag reel has shown over the years.
Yeah, back when you were at SpaceX. Yeah.
I'm gonna start looking at my life differently. I'm just an engineer.
All the failures.
Who knew?
Let me take you somewhere, because this comes up, and I want to hear it. I've spoken of it as a scientist, but I want to hear an engineer speak of this. Let's say there's some disaster, NASA disaster, okay? Always, somebody digs up an engineer's memo that said you shouldn't launch because this might fail. And then others say, Why didn't you pay attention to that? And nobody looks to all the successful launches to dig up the very same letters that say you shouldn't launch because that's going to fail, and it doesn't fail. So how do you square how NASA or any company should respond to the claims that you didn't heed advice when presumably, I'm thinking, there are memos like that every single launch?
So there's a failure in leadership there that I personally believe in, that I operate differently in my organizations over the years and my company now. You're always going to have somebody say, I'm worried about this before you launch or before you field a spacecraft on orbit. And so what I do is we have what's called active risk management, which is a NASA term, but we look at all those risks before we fly. At every organization, there needs to be a person that signs off on the final risk posture for whatever mission you're flying. And that person, it's okay for them to take risk, but they need to document why they're taking that risk and why it's acceptable. So when I build flight hardware, we do a final risk review before it flies. We look at all of the key risks. And if people feel really strongly that they're worried about something, then I say, I'm taking that risk away from you. You don't have to stress about that anymore. I'm going to say it's okay, and I'm going to justify it because of this.
Okay, so now something goes bad. Now the press comes and they see that memo. And they say, why didn't you heed the advice of that memo?
And I had already addressed that in the documentation that said, I thought this was an acceptable risk because of X, Y, and Z, and I know I have to stand by that whether it fails or not.
Okay, so now they put you in front of the bereaved relatives.
Now you're standing on a jet and the door has blown off mid-flight. How do you get around it?
Well, but
That could never happen.
I think there's incompetence and there's acceptable risk documentation. I guess that's what I was getting
That's
at.
what you're saying.
That's an important distinction.
That's it.
I make it a point to have acceptable risk documentation, so if the worst happens, I can at least explain myself on why I thought that was okay.
Gotcha.
And then I'm also fine saying I was wrong.
It's like a pharmaceutical disclaimer. You know, side effects may include, and they're highly unlikely, but they list even the most unlikely of side effects, but they say, you know, hey, listen, the chances of this happening are so slim that this is deemed safe. But there's a very, very slim chance that this could happen.
In space, there's never a guarantee. That's the thing.
There's no such thing as safe in space.
There's no such thing.
It's just the risk that you accept.
I think companies get in trouble when management takes that authority away from engineering and says, we don't care what you guys think, we're doing this anyway.
That's when you got a problem.
That's when you got a problem. So when you're talking about, you know, door hatches blowing off or submarines failing when they shouldn't have been designed the way they were or whatever, that's a failure in leadership.
Gotcha.
And so I think you're still going to have failures, and I'm just saying let's avoid the failure
That's
in leadership
interesting.
piece of that.
Not enough attention is given to where the leadership matters versus the engineering declarations of what the risk factors are.
That's right.
Yeah, yeah.
Because people just want to get to the end. and
Okay,
they
so
get
how
a
about,
retrieval.
just since we're here, the Hubble telescope, the mirror has a perfect shape, the secondary mirror has a perfect shape, but they don't play in the sandbox together, and they were not tested together. So is that leadership?
That's a failure in system engineering, in my opinion, because you didn't have an adequate test program.
How big was system engineering as a thing at the time? We're talking about
We're
the
talking
late
about
80s.
NASA. This is system engineering haven.
That's what it is. You're right.
So of
But I
all
don't think
the
I don't think system engineering was taught in schools as a branch of engineering until later than it should have.
Well,
Am I right there?
I mean, I've seen evidence in the shuttle program that they had very robust system engineering back in that time frame.
Okay,
So,
in the 80s.
you know,
then,
maybe
the
NASA
90s,
didn't
yeah.
equivalently apply it all over the different centers and
Gotcha.
programs, but there is no better place for systems engineering execution than NASA.
So that's a blunder. Somebody.
It's a failure of imagination to be like, should we test these systems before they fly, maybe?
Wow.
All right, one more. Let's go back to the Mars Climate Orbiter, where it never got into orbit because the scientists were using metric and you engineers were still on imperial units of force.
I remember you telling me that
What's
story.
up with that?
That's
That's such a
hilarious.
classic story and true. What's up with that is we've carried mixed units in the United States for way
Oh,
too
be
long.
blaming the country. All right, blame it. You're the engineering people. You know you're talking to scientists. You know.
Well,
You want the scientists to be using pounds and ounces?
I'm not going to make
We're not.
I'm not going to make excuses.
That's
for
right. You better
engineers,
not.
But I will tell you why it's happened, in my opinion.
Okay.
A lot of the engineering tools for spacecraft and launch vehicles were all written in imperial units. And so they've been very slow, the community at large, to change those tools to a metric standard.
Okay.
And so engineers get lazy because they want to stay in the units they're comfortable with.
Well, did that scenario cause them to make the change, or are they still doing the same?
Well, they're still being dumbass.
I think there's
That's
still...
your word. You say it.
Are they still being dumbasses?
I think, Chuck, there's still pockets of dumbassery going on.
Oh, that's a Chuckism right there.
There we go. It's fantastic.
The dumbassitude of the system
That's
just
right.
doesn't. So we've seen in recent months a move to cut costs at NASA. Cut costs in many ways, including the science budget, I think got the biggest cut. And there's some attrition, people leaving and not being replaced, early retirement. And so it seems like we're losing some legacy wisdom with that shift. Could you reflect on what you think might be the future consequences of this?
Absolutely. What comes to my mind, there's two things that I actually worry about now, which is we're watching our scientists walk over to other countries because there's no funding for them here.
I have two colleagues, not in astrophysics, but in other physical sciences, that said they got a phone call from France.
Yeah.
They say,
Hello? What are you doing right now? I hear you are being fired. Perhaps you would like to come to France
so
and make a baguette rocket.
Be tasty.
that would be funny. Rocket in the shape of a baguette. Dude.
But like, so you've got the scientists vacating, and then you've got NASA engineers and folks that will not be doing the fundamental research. We've been robbing R&D from the United States for, my career has spanned 30 years at this point. I can't talk to all the things that happened before me, but I can talk to all the things that happened in 30 years in my experience. And it was bad when I started my career. It's even worse now 30 years later. I think current events are going to have ramifications for America as a leader in science and technology for decades to come because of what's happening now.
We're plundering our own intellectual treasure, is what we're doing.
Because you don't know which experiments are going to work.
Right.
You have to fund a lot of different science and technology areas, hoping that 1 out of 10 or 15 are going to be winners.
Why don't they know this?
I don't know. I guess that's why I'm here. Let's get the word out.
You should be on a podcast.
I should think about that.
Let's work on that. Gosh. Speaking as an academic, if I come up with a great idea and I publish it, and then all my colleagues see it, they can judge it, see if there's a flaw, or use it as a stepstone to reach a next goal. That's the openness that is fundamental to the progress of science. You're in a competitive industry. If you make some discovery, would you be resistant to patent it because then other people would see it? How does intellectual property work in your business?
There is a strong desire to hide things that are unique because it becomes intellectual property and IP of the business that can actually add to its value.
So tell me things you're hiding now.
So, sure, I'm happy.
No. I'm just
Remember that warp engine you talked about?
So one of the things as a CEO of a space startup that I think about a lot is integrity. And so to your kind of what you're scratching out a little bit is, if there was something so great that could benefit humanity, I learned a lot from Paul Allen when I worked for him, because one of the things I took...
Microsoft Paul
Allen. And one of the things I took away from Paul was technology for the benefit of humanity. So that's one of our kind of cultural touchstones at Portal Space Systems. So if we had something so great and so beneficial to humanity, I wouldn't want to hide that. But that's just my take on integrity.
And what does your wife feel about this?
Well, we should talk to her about that. It's probably going to come down to the value and the dollar. I think she'd rather have a husband with integrity than without. It's what I think she'd
There
probably
you go.
say.
That's a great answer. Yeah.
But we don't have enough integrity in the business right now, is a personal observation. because the push to make money, the push to grow a business and satisfy investors sometimes compromises people's value systems in ways that aren't great.
So how could that, because it seems to me like what you're doing is either comes down to this works or it doesn't. So I'm sure there are people who feel like, well, what do I need integrity for? Because it either works or it doesn't, so what difference does it make? Where exactly does a lack of integrity hurt the business and then subsequently
I think lying about the progress of your product. That's where
to keep the money coming.
That's where I see it the most.
I see.
Vaporware.
Businesses are trying to drive for that next fundraise,
Gotcha.
that next investor,
Okay.
and they lie their asses off to get to the next step.
Okay.
And that's where I see it the most.
Vaporware. That's what that is.
I don't know what vaporware
Well,
is.
there's software.
Oh, vaporware.
There's hardware.
Oh.
There's wetware.
Wetware, yeah.
Which is the brain.
Right.
And then
That's
there's
us.
vaporware.
And vaporware.
It's just vapor.
Yeah,
There's nothing behind the
That is
idea.
my Uncle Jimmy at a cookout. Vaporware. Yes, I didn't have a name for it until now.
So take me back to the billionaire boys space race. I mean, they're billionaires and they had the cash. How does that work compared with someone who has a brilliant idea and just gets VC money to come in and help him?
Yeah, well, with Elon, he had that money from PayPal to start Tesla and SpaceX. So he had a $100 million head start that most people don't have.
VCs will come up with $100 million. You can get that.
I mean, you have to work at it. It doesn't happen that fast.
Okay.
Normally you still end up going through a process where you're going to raise a pre-seed round of a few million and then a seed of maybe 10 or 20 million and then blah,
Plus you
blah,
owe
blah.
the VC at the end, where if Elon is spending his own money, he just owes
You're
himself.
diluting your business every time you raise money.
Yes.
And Elon didn't have to do that because it was his own
It's
money.
his own money.
To begin with.
So let me ask you, because I'm just fascinated by this whole thing right now. How does a VC know anything about thermonuclear propulsion? I mean, seriously, I need $30 million.
This is where he's got to be a salesman.
Yeah. I mean,
So when we started the company 4 years ago, we decided to pursue solar thermal propulsion because it was a stepping stone to get to nuclear propulsion later. But nobody knew what that was or how it could translate into getting you faster movement on orbit. So you're right. The CEO has to be a salesman first, and then you have to start proving that you can build this hardware. And then you start building hardware, you start doing testing, you start showing people.
Plus, you're going to assemble a board of some kind who's looking over your shoulder.
I've started to do that now, with where we are.
He hadn't do that.
he didn't need to. Now you made him actually say it publicly.
I have a board, but it's a small board. But
his mom is on the board. You're doing so well, son.
that's a good idea. That's a good idea, Neil. I hadn't thought about that.
That's funny.
No, you need some skeptical physicists on your board to know what's possible and what isn't.
That's true. I can always use good skeptics on the board.
Yeah.
Yeah, but the investors typically don't know anything about the technology, to your question. And they hire people.
And that's not unique to space, right?
No.
Almost all the high-tech frontier companies, VCs just like the idea.
So one of the things we did at Portal was we started working with the Space Force and the Air Force on small business innovative research contracts so that we could show people that knew things about space, that knew the technology, that investors could then get confidence on that we were on the right track of things. So there's just a lot of steps you got to take to try to convince people something's real. And I wanted to do that with data as much as salesmanship, because I didn't want to be vaporware.
Okay.
So could you give us a kind of overview on the history of propulsion and how the ideas have landed, what's working, what has underperformed relative to predictions, what has overperformed? What we do know is that we don't really have flying cars. We have these flying drones, okay? They want to call them flying taxis, but they're helicopter drones, right? So in the old days, there was just simple Goddard liquid propulsion that you can throttle, I guess. It's chemical energy.
Yes,
We're still using chemical energy.
we are.
So what's up with that?
Well, to get out of Earth's gravity well, You want a lot of thrust, and liquid rocket engines are still the best way to get off the ground and into orbit. Where technology is now started to evolve is once you're in orbit, now what do you do? I would argue that liquid rocket engines aren't the best way to get you around once you're on orbit. Now, we're still using that to take upper stages, third stages, second stages to take you to higher orbits and stuff, but that's not the most efficient way to go. And so they started to see this with...
So there are these regimes.
Yes.
There's acceleration regime, delta V regimes,
Yep.
that don't call for the same solutions.
Correct. There's more solutions available than what we've typically used before.
Okay.
So electric propulsion came on the scene a while back.
And tell me how that works.
So typically you're talking about a Hall thruster type system. So you're creating ions that you're accelerating out the back of an electric motor or engine.
Why isn't that an ion engine?
It's an ion engine.
Oh, okay.
Yes.
Okay. Right. I thought it was something different, but it's not.
Electric propulsion ion engines are in the same family. They're very efficient, but they don't have a lot of thrust.
Right.
So because you're not creating the acceleration, because you don't have a lot of thrust, you don't get anywhere very fast. So satellites said, okay, that's cool. If it takes us weeks or months to get to an orbit where we're selling electrons for broadband internet or TV or whatever, that's fine. But then our adversaries started developing spacecraft that could move a lot faster with higher thrust. And then they started doing things on orbit that threatened some of our critical infrastructure. And now we have no way to kind of maneuver around that.
So there's strategic value
Yes.
to this.
Maneuverability is a key ingredient of warfare on land, sea,
And
air,
space now.
and now space.
You think? So chemical rockets, we are removing energy that was built into the molecules that are in the fuel tank. That energy gets released. Yep. You expel mass out one end. The rocket recoils by going the opposite direction. Newton's laws.
Yep. Accelerate those particles in the thrust chamber as
With
fast
very
as possible.
high mass, high speed coming out the back. Once you are in place, you now kick out ions, which have very low mass, but high efficiency. And so it'll move you if you're patient.
Yes.
And so these are two different needs,
Yes.
clearly. Okay.
And now there's a new need, which is we don't have that patience any longer.
Right.
Got it.
Now, what are I'll say our adversaries? What are they using for maneuverability?
Well, if you look at what China's done, as they've grown the amount of mass they can throw with their Long March launch vehicles, they're just making bigger and bigger spacecraft with bigger and bigger tanks and bigger thrusters.
So they're brute forcing it.
Yes, sir. That's
Okay,
correct.
that's what they're doing.
And we like to be more elegant.
Yeah.
Remember my story about the Russian rocket?
Right,
Versus
exactly.
American? We always want to think about everything.
Right.
As my wife often tells me, I'm in my head too much. That's very much an American.
But you know what?
That could
I
happen.
kind of feel like precision and elegance wins out in the long term if you can get past the short term.
And commercially, yes.
Yeah.
Because you need that elegance to hit a price point that's going to make you both commercially viable and viable for the defense industry as well.
Yeah, and unlike America, they spend as much money as they want on anything that they want.
Well, and China's completely aligned in their military-industrial complex.
Right.
Yeah.
I mean, there's only one
There's one
chain of command,
chain of
command.
one person that makes those
Right.
decisions.
Exactly. And that's what I want here. That kind of efficiency.
He channels Trump. He can't help
Donald J.
He
is
can't,
my
he
name.
can't help it. He can't help it.
I'm sorry.
So, is there anything you could testify in Congress today that's reminiscent of what you testified back in 2015
That would let them
about
know
our
that-
needs,
and to
the
let them know
transition of our needs?
what kind of dumbasses they are. Because they are dumbasses.
So
I'm sorry. I'm sorry.
the interesting
we
thing,
can cut that out. Please don't cut that out.
the interesting thing about all of that is that when I testified before Congress in 2015, it was about why are we sending all this money to Russia and buying their engines when we've got engineers we need to train in the United States and we have commercial companies that can do the job? And that was my argument. And I said, hey, Falcon 9, Falcon Heavy, Starship Raptor are coming. It's going to be a thing. Fortunately, I was right on all of that. What I would say today to different committees before Congress is our adversaries are coming for us and we are cutting R&D spending, we're cutting engineering, we're cutting science, we're cutting all of the things we need to be competitive.
We're also spooking immigrants
Yes.
who could have expertise, as they've always had.
Yep.
I mean, when I was in graduate school, half of my fellow graduate students were foreign nationals. Half of them. And now they're all spooked because they don't know what's going to happen.
Yeah, and China's made no bones about they want to be the preeminent superpower in the world. So I don't know why we kind of have our heads in the sand about this.
No, it's ahead of our ass. Say it right.
Okay, sure, head up our ass.
That's a darker place than in the sand.
If I was testifying before Congress to your question, I would be hitting those points really hard because we need to be accelerating capabilities that are going to preserve. I want to preserve low Earth orbit, mid Earth orbit, LEO, cislunar, around the moon, for commercial opportunities in the future. And so my thesis is, if I don't do my part to protect and defend it with the Department of Defense, there's not going to be a spot to make money commercially in the future. And that's how it's been. So we started sailing wooden ships. The pirates were there. It's going to be no different on orbit. So what are we going to do about it?
Yeah, and so let me describe what I think is going on in space, and you either say I've got it right or modify it as necessary. But when people hear Space Force, they say, oh, there's going to be weapons and bombs in space. And it's not really what's happening there. What's happening there is our assets that enable what we think of as modern life and civilization are fundamentally pivoted on what we have orbiting this Earth, with the satellites, the GPS especially, our other communication satellites. And so if you have a military, it's not, oh, defend this border, take this hill. No, it's defend our assets. And our assets are bare-assed in space. And an adversary who wanted to take us out, blind us, they would go to our communication satellites and take us out.
Just like Independence Day.
It was Independence Day. You remembered that.
That's right.
The aliens came and took out all of our satellites.
Leave the World Behind on Netflix.
Oh, that's another one.
That's a great one.
Leave the World Behind.
Yes.
It was a tech warfare. It's
Yes. Do not watch that movie with Neil Black.
not.
Oh, I think that'd be fun.
No.
No?
Leave the World Behind. That was actually, I think the Obamas were executive
Yeah, they
producers
were.
on that project. A terrifying movie, actually. Leave the World Behind.
Well, to your question to me,
Yeah, so would you agree with how I
I
characterized it?
loved how you characterized it because that's the same message that I try to send when I'm talking to, why should the average citizen care about this? They should care because when they go to the gas pump, it's not going to work because GPS does the timing for the gas pump. When they go to get cash from the ATM, it's not going to work because GPS does the timing for the ATM. We've selectively tied our financial systems to GPS, and we did that. We made a choice. We said, oh, this is cool. Let's do this. This is handy. China did not do that. They have other ways they do timing for their banking and financial assets.
My money's in my mattress, so
And not just China, but other countries, right? So we made fundamental decisions with our space technology that have made us vulnerable, to your point, which is why people should care so much about
And
this.
we have battleships and Marines that could do 100 push-ups and launch silos, and any country that's smart is not going to attack us on those grounds.
Right.
It's going to you're just going to find a weakness. That's how any war unfolds.
Well, and guess what? All those assets up there right now, can they move when they're threatened? Can they defend themselves in any meaningful way? I would argue probably not.
And I also heard, and I haven't confirmed this, but I heard, and you would know, that some adversaries will have satellites that'll nestle up next to our satellites and just basically harass them, either with an electromagnetic field or something. And so we then have to move our satellite away from them to maintain operability, but that uses fuel that we otherwise need to station keep. And so that will reduce the lifespan of some of our satellites because of this. And no, did it fire a weapon at us? No. Did it destroy us? No. It's just
cyberbullied us.
Yeah.
This seems like a very reasonable hypothesis to me.
Yeah, I heard that, and that was
very diplomatic.
It's another way to mess. So Space Force is not.
Jeff did not answer that question.
Protect our assets.
Did you see what he just did there?
What he did?
He was just like, it seems like a very reasonable hypothesis, which is like, oh man, that's exactly what is happening.
I was trying to channel my inner Neil.
No, that was good. That was good. That's why I had to point it out. That was excellent.
So in your current capacity as CEO of, give me the full name again?
Portal Space Systems.
Portal Space Systems.
You'll have to ask me how about the name of the company at some point.
I'll ask it now. How'd you get Portal Space Systems?
I used to watch Rick and Morty with my daughter.
Excellent.
There it is.
And so half of the story is the portal gun from Rick and Morty, because that's what I used to watch with my daughter.
You know, Rick and Morty is just Back to the Future relationship all over again. It's Doc and Marty.
Yes, that's right.
Rick and Morty, Doc and Marty. And he's got the same kind of, hey, Morty, come on.
That's right, Marty.
We got to go.
It's the same. Yeah.
That's very cool.
So tell me what's the coolest thing you're working on in your company right now?
So Supernova has been like
Supernova.
the flagship.
You took one of my words.
Yes.
My people.
Well,
that's our word, just so you know.
I wanted to be close to your people.
Yeah.
But we kind of have a star theme with our products at the
Love
company.
It. You know I'm going to love that.
I knew you'd love that because I love Cosmos. So I
Good.
mean, with Supernova, it's about that rapid movement. And it's Supernova because we're using concentrated solar energy, and we've innovated around a heat exchanger, so we don't have to combust any liquid propellants with our system. So like a nuclear...
But this is towards what end?
This is so I can carry twice as much fuel, and I have a thermal engine cycle where I'm not using combustion. So I can have fewer parts, more efficiency, higher thrust, and twice as much fuel because I'm not carrying an oxidizer, so I don't have to burn anything. And I really wanted to do nuclear thermal, but I can't buy a nuclear reactor at Lowe's, and there's not enough of them to buy right now. So
10 to 24 gigawatts. Gigawatts.
Yeah.
You can't get one of those at Lowe's?
I want
at Home Depot?
I joke about this all the time because the thermal engine is a lot like Mr. Fusion from the second Back to the Future movie, because we use ammonia as our propellant now, but we could use
Mr. Fusion was in the first.
Okay, yeah, at the end.
At the end.
At the end, yes.
Which get you to the second
Gets
movie.
to the second. You're right.
Yes, get your movie. You don't just don't with me here.
I like this. I like this battle of the trivia. So the thermal engine's a lot like Mr. Fusion because we can use ammonia, which is our baseline fuel, because it's very storable on orbit, and we have a multi-year life of our spacecraft. But if I want to start moving out to Mars and I want to use methane, in the future I want to use hydrogen, I want to use other things, I can use other fuels in a thermal engine system.
Oh,
so this
has versatility.
Is versatility because I'm very much a live off the land kind of guy when it comes to space. If we're taking everything with us, we've failed as engineers.
That's so cool.
You know, could you tell NASA that that's what they should call it instead of in situ resource utilization?
Living off the land.
Let's from now on, NASA, are you watching?
LOTL, okay?
Living off the land.
There you go, NASA.
That is way more marketable than in situ resource utilization.
Yeah.
ISRU. That's a big branch of NASA.
Heads up, NASA.
Yeah.
We're coming for
There's
you.
a cool company down in Florida. I'll give them a shout out. They're called AdMen, and they are an additive manufacturing company.
Oh,
and
AdMen.
that's what they.
Cool.
That's what they work with on all the space people that they work with.
Right, because if I'm going to Mars, I won't think of all the things I need to live, but I want a print machine that can print any tool I need once I'm there. But anyway, so with Supernova, it's about propulsion, but it's about payload flexibility. So what that means is a software definable power, which means you have a payload, you have a camera, you have a robot arm, you have whatever you want to do whatever mission. It's like a Lego brick onto the front of the payload deck. Perform your mission. I'm selling, I'll get you there as fast as you need to be, and I'll give you a platform that's very versatile over multiple years.
Not to stupidly simplify it, but are you saying you have a warehouse and I have a need, and I say I want to put this object on Mars and do some things, and you say, yeah, get two rockets from aisle A and 2 boosters from aisle B, and then we assemble what it is that will serve my needs?
Well, from a spacecraft standpoint, yes.
Okay.
So I am going to build you the spacecraft, and whatever you need on that spacecraft to perform a mission, whether that's a camera or a telescope or whatever, I can supply power and data to that.
That is engineering heaven right there.
That's wild.
Because that's one of the biggest problems with satellites right now is everything's bespoke. So you want to have a telecom satellite. Oh, I'm going to build the whole thing, including the telecom payload.
And that's
all
way
it does.
more expensive.
Yeah.
The one-off. It's a one-off.
And if your customers don't show up and want it, then your business fails. I can't predict everything the customer needs, so I didn't want to try. I just wanted to give them a spacecraft that could meet all their needs.
Wow.
Okay, so when are we having warp drives?
And when
Right now, tell me.
and how do we get in on the ground floor of your company?
Let's talk afterwards. Talk on the side. We can make that happen.
What's on our doorstep? What remains only in the dream states of engineers?
I think two things. If I was king of American engineering for a day, for space, I'd accelerate AI and machine learning and get more robots and AI out there doing the heavy lifting for us.
It's called Skynet. You know, you realize
I get that, but I think you could. I think
would accelerate AI and make more robots.
I'd make more robots.
You need a different starting phrase.
But let me tell you why I said that. We spend so much time and money trying to keep humans alive that it slows our pace of exploration on orbit.
Slows everything.
So let's get AI and ML out there on spacecraft, exploring the solar system, and teaching us what we don't know yet.
ML, machine learning.
Yes, machine learning. So that then we can engineer the systems that keep people alive and get it right the first time. And we can get more exploration done faster because we're not spending all this money to keep people alive right now. Let's go learn what we need to learn to keep people alive.
You better not name the robots because then people will feel for them. And if you don't bring them back, that means you kill the robot.
I'm okay with that.
Yeah, I haven't made up my mind about that.
I'm just saying, there's a whole ethical frontier there about feelings for things that have
There's actually an ethical society that has come up around the treatment of robots.
I guess I would tell those people it's easier for me to keep your robot alive than a human alive in space.
You got my vote with that one.
There you go. There you go.
And then on the propulsion side, I think what we're learning in quantum physics, this is where I'm going to carefully delve into your universe for a hot second. I am not the expert in quantum physics, but I do read a lot because I'm super interested in what we're learning there. But I think there's elements of the quantum world that are going to unlock propulsion technologies that might look similar to a warp drive, but I think we need to unlock some more understanding of the quantum universe to do that. I think that's going to be the linchpin giving us sci-fi geeks the warp drive we want.
So a quantum FFRDC would be a cool thing.
That would be an awesome thing.
Right. It's just everything quantum.
And you could probably get that funded because there's a lot of defense applications for quantum as well.
Right. Okay, so give me an actual date where we're going to have a warp drive so I can put that on my calendar. We know when the warp drive gets invented. It's 2063.
Correct.
In Star Trek.
Right.
So those are your marching orders.
Okay.
Okay.
I think we can do that.
You've got 40 years.
We're moving fast in quantum.
It's via the quantum.
Via the quantum.
Okay.
I think that's our best path right now.
All right, because if even in Back to the Future Part 2, they predicted that the Cubs would win the World Series.
And they did.
And they did. Yes.
Yeah.
But
even a broken clock is...
It's true. What did it say? A blind sow finds an acorn every once in a while.
There you go.
But I think that with warp drive, it's not about this propulsive thing that we're all mentally geared to. It's how do we leverage quantum to manipulate the fabric of space-time.
So quantize gravity and things of that nature.
You have to you're going to have to figure out how to fold
We need a
space-time.
new understanding of the fabric of the space-time continuum.
Nice.
Manipulate that. It's not even about propulsion.
Propulsion,
Yeah,
yeah.
that's right.
Right. Yeah.
That's Thornberg's theory, anyway, for whatever that's worth.
Oh, okay. So, Jeff, we got to land this plane. But, Chuck, do you have any last questions for the man?
Yeah, I'm just interested, what would be the ultimate achievement in commercial space travel, or the holy grail? What is it that everybody wants?
I'm going to tell you what I want, and then we'll go to him.
Go ahead.
I want to go suborbital to between any 2 points on Earth, so that I'm 45 minutes. I'm no more than 45 minutes away from lunch in Tokyo, and then fly back.
Wow.
So that would require rockets, not planes.
Yeah.
Because orbit is 90 minutes.
Right.
So if you're suborbital and half of that, you just go the other way. You can go anywhere in the world. And I think about that every time I go to Washington. I go to Washington for a lunch meeting and then come back and I'm home for dinner. And if you told that to our founding fathers, get the horse ready. Martha?
That would be an impossibility.
They'd be like that way. So pick that up. What awaits us?
For me, my holy grail is that humans can go to any orbit between here and the moon or the moon, it isn't a significant emotional event. It's
That's
just
wild.
a standard
Going
way
to the
of
moon, I'll
life.
see you on Tuesday.
Exactly. That's wild.
That's what you want.
That's what
Yeah.
I want.
So
In my lifetime.
cislunar space becomes our backyard, not even worthy of comment.
Correct.
Look at that. That's very cool. It's like saying, I'm going to Poughkeepsie. I'm going to the moon. It's all the same.
It's all the same.
All the same.
That's a worthy goal. I like that. So let me perhaps offer a cosmic perspective on this. I'm a scientist. I think sciencey things about the world. And at no time am I asking, how would one accomplish this? How would one build it? How would one pay for it? How much ingenuity does it require? Do I have to invent something that has never before existed just to solve the problem I have posed? I don't really have to think about that. And we have this community of engineers that walk among us who live for that. They live for it. You know what else they live for? Constraints on what it is they need to do. That was the most